things and in my chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and in my chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Test, test. The chat. Long time. Been a minute. Sorry, I'm just setting up. Congrats, Paul, for the new offer. Let me just make sure everything is set up. What blue text? Cyclops, what's up? I got a new like microphone stand, so the audio should hit different. Yo, what up, what up? Hey, how's all the interviews going? I know you had the Amazon one. We were prepping you for a while on that one. Yeah, they let you choose everything. Oh, it's on Tuesday? Hold up, just setting up real quick. Do you have a session with me today? I chose the Pixel, but the main reason I chose the Pixel was just because... How's the audio, by the way? How's the audio? The main reason why I chose a Pixel... Holy, give me a sec. Let me close off a few things. Yeah, the leadership principles. I memorized those by heart. Mars, what up, what up, what up? Test, test. All right, audio's slapping. Let's do some coding interviews. Got the first, dude. Damn, pass your Amazon OA. Congrats. Those are hard to pass. Those are actually hard to pass. Those are not easy. Even to this day, Amazon, those Amazon ones, I struggle with. Hold up. This thing's gotta be annoying. Let me set up a couple things. Yo, what did they ask you? What'd they ask you? Alright, we got somebody coming on for coding interview. Let me just set up like my subs count. Man, it's nice to get back on the stream though. It's been so long. JP Morgan Chase? No, I don't know much about it, but people in the chat should. Lots of people I know have interviewed there in the people in the chat. Could I get a resume review? Send it in the. I did so many of those, but send it. Have you seen my video where I did like a ton of looking at over people's questions? Or sorry, looking over people's resumes. But send it over in the Discord. If you send it in the Discord, we can go through it. Hold up. What happened? Zero, what's good? What? What's going on? Wait, I'm just trying to find an account with CoderPad. I used up all my CoderPad. I should probably just pay for CoderPad at this point. Matthew, what's up, man?
Hello.
Yo, can you hear
How's it
me?
going?
What's good?
Can you
What's
hear me?
good? What's up? What's up? Can you hear me or
Uh,
not? I'm on
yeah, I
stream, so
can hear
sorry I
you.
don't have the my. It messes if I put on both cameras. So, chat, could you hear him? You're on stream, by the way.
Okay, that's all good.
All right, hold up. Let me grab something. Give me a sec. How you doing? Prepping for
I'm
interviews?
good, thank you. Yeah, I have some mostly just always coming up, but I had some interviews that I did. Um,
Where do you have?
so I'm
What do you
just
say?
trying to. Oh, maybe I should switch my mic. Give me a second.
All right.
Is it a bit quiet?
Chat, how does he sound? Could you hear him? I feel like it's good. He's fine. Yeah, everyone's saying you're good.
Okay.
All right, give me a sec. Just setting up. I'm gonna send you the coder pad link, and then we can get into intros and stuff.
Okay.
Here, just hop on the coder pad.
Okay, I think I'm in here.
All right, sick. So, what are you studying for? What year are you in and everything? Oh wait, we'll just do this in the
So I
intros.
just
Actually, let me kick off the intro. I'm gonna drop this as a separate video. Chat, the audio is all good. Everything's good. All right. Okay, I'm gonna start this up. All right, give me a sec. Hey everyone, so today I have somebody joining in from the University of Alberta. Solved around 150 leak code questions. So yeah, want to introduce yourself? Like, are you starting to interview now? So you want to do some practice, or what's up?
yeah. So yeah, the name is Matthew. I'm from or I go to the University of Alberta. I just have some interviews coming up, and just I'm getting a lot of OAs, and I've been doing bad on them.
Yeah,
I've just been practicing, trying to get up my skills, so I don't mess up opportunities when they come.
yeah.
So
I mean, if anyone
yeah,
doesn't know, University of Alberta is a pretty good school. It's one of the top schools I'd say in Canada. So I'm happy that you're
yeah.
getting interviews. What year are you in?
I just graduated.
Oh, okay, nice, nice. So now
Yeah,
you're trying to go for full time.
yeah. Trying to find full-time stuff currently.
How did you do any
Yeah,
internships or anything?
I have one. Like I was honestly slacking a lot during my degree. I should have been more aware or trying to get internships, but I wasn't.
It's
I did
fine.
have one, but yeah, it's making the job search right now harder than it needs to be, but
Yeah.
it's fine.
No, I'm happy you're
Yeah.
getting interviews though. So, are they? What kind of companies are you aiming for?
Um, I'm just usually I have better luck with like local companies, ones that are closer, like around Edmonton, um, which is where the University of Alberta is.
Yeah,
Um, yeah, some stuff in Capital One.
nice.
That one's in the US. But mostly local stuff. I had an OA, I had some stuff on Amazon, but I did so bad. That's when I knew I needed to start practicing lead code after the
Yeah.
Amazon OA I had. So yeah.
So what are your leak code skills right now? How good do you think you are?
Uh, I think maybe medium level or not. You probably know the Need Code 150 list.
You done it?
Yeah, I did went through the whole list. So I've just been grinding out lead code recently for the past 3 months.
Yeah. All right. Okay, we're gonna simulate a real coding interview. I don't know if you've ever done one, but pretty much you're given this interactive code editor where we're gonna be writing all of our code. I'm gonna ask you 1 to 2
Okay.
questions, about 20 minutes per question, and yeah, we'll treat it like a real coding interview, and let's see how you perform.
Okay.
Okay, let me think of a good question. Um, so okay, so what I want you to create, this is gonna be pretty vague, so we need to work through all the requirements. But I want you to create me a W linked list class. W linked list. Does that make sense?
Or is that the whole question?
Yeah. I want you to create me a W linked list.
Okay, so you just want, okay. I can go ahead in Python, right? That's good.
Yeah.
Okay, so
So what's the strategy for implementing this? Are you familiar what a linked list is?
yeah. So, oh, sorry, my bad. I should have explained first.
Yeah.
Okay. So the way I'm gonna do this is I'm gonna start off by having, so a link is essentially I have a node that like connects to another node, and that's how a linked list is formed.
Mm-hmm.
Usually a singly linked list, you can only have them going in one direction. So you have one going to the next, but a doubly, you can have them going backward as well as forward.
Mm-hmm.
So that's what I need to implement here. So in this class, what methods do you want me to implement? Do you want me to have like a way to, I'm guessing a way to initialize it to be empty,
Mm-hmm.
and you want an
Yeah.
insert method as well?
Okay. We'll say we want to be able to add at head, add at
Okay,
tail. We want to be able to then remove from head, remove from tail,
okay,
and then search, and then um, add at index. So
okay. And
that's what
for
I
that,
need to know for now. Actually, let's change this up a bit. Sorry. Let's remove from head, remove from tail, remove from index. Add. So these are the 6 operations that I want you to create.
okay. And I'm guessing the remove functions will only be called if there's at least one node in the linked list, like the remove from head and remove from tail.
Yeah, exactly.
Because if there's, okay, so I'll just start off by initializing it.
So I'll give you a quick hint right
Uh,
now that we should probably try to iron out the approach before coding, just because in case it gets complicated, we need to make sure that everything's planned out, and that's usually the best way to approach these interviews.
okay, so um, so I'll start off, I guess, by the adding at the head. So what I'll do for then is I'll just take the current head, then I'll just move the forward pointer or the next pointer to the node I'm adding. And that new node, I'll edit the previous pointer to point to the head. So
So which operation are you talking about?
add that head.
Okay,
I'm gonna implement this one first.
sure. You can add a head.
Oh, wait a minute. First, I actually need to create a node class here for every single node in the linked list. So for this one, I'll have this be. So I'll need um I'd have three values, right? I'll have the value of the node. Start off with 0, and then I'll set that to be the value. And then I'll have the next and the previous for every single node. So, or actually, yeah. So I think that's how every node's gonna look like in the linked list. It's gonna have a value, and then it's gonna have what it points to in the previous one. Um, of course, to initialize the W linked list, I'll need just create one node to be the head. The problem is, hmm, actually, maybe I should just start by implementing the added head. Do you need something to initialize the W linked list?
What do you think? It all depends on your design, really.
Okay. Because if I want to add at the head, I can't really add if there's nothing there to add yet. Or then maybe, oh, I could just check actually if there's a head. So for the added head, I'll check if there's a head. If there isn't one, I'll create it. Or if there is, then I will just go ahead and append the new node to it. So this one will be and then for the value of the node, I'm guessing for the linked list, you just be given like a number, right? Like an index for each node in it.
Yeah, we can just pass in a value.
Okay. So I'll check if there's a head for the W link list, then I'm able to just easily do the connections. So if that's there, then I'll do self dot. So actually, first I need to create this node. So I have this equal to this node, the value. Why is this not working? Oh, okay. So now if the head exists, then I just need to connect the head to this node. So the head dot next go to this new node. And then the new node dot previous to the self dot head. And then remember head is on node. Um, just because I didn't initialize it. Yeah, let's set the head here. Okay. So if there's a head, then I just make this connect to the new node, then the new node previous connects to the head. And then I need to, uh, I think that's it. If the head does not exist, are you able to hear me?
Yeah, I can hear you. Just watching,
Okay.
just analyzing.
Good. Uh, if the head goes, then yes, I just move head next value to the new node to the previous one. And I don't need to change the head here because the head already exists. Else, in this case, then I'll just make that head equal to this new node. Um, I think that's it for this method. Just double check. New node is equal to new. No, new node with previous of the head and sub the head is equal to the node. Okay, I think that's done for that method. Is that good?
So we're adding at head. So what are we doing? We're creating a new node. And we're pointing the
Yeah,
head dot next to the new node.
yeah.
So, well, we want to, when we say add to the head, we want this value to be the new head.
Oh, okay, I misunderstood that. Okay, so if we want this new value to be the new head, then
So pretend we already have this linked list. This, right? We want to add 0 to the head. It should go here.
oh, okay, I see. Then I need to do this. Uh, I'll d no, okay, I need to change this a bit around. So this new head. Oh, okay. So I need to flip this around. So actually, I'll save this. I'll use this one. I'm guessing this one will probably be for add a tail. Let me edit this around then. So then that means that this new node dot next is actually going to be the head. So point to the old head. And then, yeah, it's going to point to the old head. I think that's just it, actually. You know, the next points to the head. The previous is going to be null because there's no thing behind it. And then I need to edit the self.head previous. And then now, okay, those. The next equal to self.head, self.head. Head dot previous is equal to the new node, and now the self.head now becomes the new node. Else, if there's nothing in the list, then the new node just becomes the head.
Self.head.previous equals a new node. Okay, self.head. Okay.
Okay. I think that's good for, is that good for added head?
Let's try dry running it. Try dry running it right here with a few examples. Say we want to insert one,
Okay,
two, then 3 at the head. How would that look?
okay. So if you want to insert, for example, 0 here at the head, so we'll create the new node. So we'll have a new node here with value of 0, and the next will be equal to null, and the previous will be equal to null as well when we create this new node. And then here, if self.head, here, this already has the head. So we'll have, this will return true. So we enter into this block. Now this new node dot next, or actually maybe I'll go here now. The new node dot next will now be equal to let me post this here.
You just
Will
try
now be
writing it
equal to
down
the
here.
self.
It's cleaner in
Oh,
these comments.
okay, okay. So I'll start off by trying to, so with the zero value, we're in here. So the node would have been 0. And then we'll do new node that next is equal to self.head. So
Well,
this will now point
we
to
want to
1.
insert 1, 2, and 3 here. This is what we want to insert. 1, 2, then 3.
Oh, into the list.
Yep.
All these values in.
Yep. Say we call it
So we'll start.
insert 1, insert 2.
Okay, guys. So for the first call for insert 1, what we're gonna do is we're gonna create the new node with a value of 1, and then if self.head, since nothing was added to this list yet, there'll be no head. So we'll enter this other block here, and then we'll just set this 1 to be the head. Now when we go to insert 2, we'll create the new node for 2. And since there is a head, we're gonna put new node that next is equal to the current head. So 2 is gonna point to 1. And then this self.head the previous. So the previous head was 1. This 1 is now also gonna go back to 2. I don't know how to put an arrow going. Oh, maybe I'll just go like this. And then 2 now becomes the new head.
Okay.
Now if I go to insert 3, I'll create the new node with a value of 3. And then since the head does exist, this new node the next will point to the old head, which was 2. And
Nice.
then the old head previous value is going to point to the 3. And then the self.head now becomes 3.
Okay. All right. So if I wanted to debug this, as in like print out the list, could you write me a function that prints out the list?
Okay. So go print list. Take in yourself. Oh, why is it? So while self.head. So while we have the head, we'll print the value. Head dot value. And then self.head is equal to self.head dot next.
Okay.
I think that
Is
is
there? Could you just, or could you see if there's anything that could go wrong by printing the list this way?
okay. So while I have a head, then I print the value of the head, and I set the head to the next value. Um, oh, wait a minute. Okay, I see what's going on. The problem is that I'll always have, or self.head is equal to self. I'm gonna be messing up the list. So I want to preserve the list, right?
Yep.
This way, if I'm like modifying the head, then I won't be able to print the list again in the future
Exactly.
because this self.head will be equal to null. So I actually need to create a temporary value here. So I'll set that to self.head. And then while I have that value, I'll print the current value, and then go to current next. Okay, while print current value, current is equal to current dot next. Okay, I think that's good now.
Nice. Okay. So let's go test this code, like run it on these insertions and then print it and see.
Okay, so um, the head 1 and 2, 3, and then print rest. Okay. Not why does it look like that? Let me see. Oh, yeah, I mean, yeah. Okay,
Nice.
so it does work.
Cool. All right, let's move on to the next. Add a tail.
Okay, so if we want to add a tail now, we'll need a tail here. So we'll set the self.tail equal to none. Um, oh wait a minute. Okay, this becomes a bit more complex with the self.head. So here, when I create the head, if it doesn't exist, I think I'll need to modify the tail here as well. So, um, self dot tail will be equal to the self dot head. Oops. Yeah, because if I'm adding for the first time at the head, then that means there's no tail, so I'll need to set the tail as well. Okay. So now, um, let me go back. Now I do the dash add tail. Okay. Now I'm trying to add at the tail. Okay, so similarly, I'll create the node that I would like to add. I'll just do that. Okay. If there's a tail, then what do I need to do? I need to set the tail, the old tail, the self.tail.next equal to this new node, and then new node dot previous be equal to this self.tail. Okay, and then self.tail equal to this new node. If it doesn't exist, then I need to do something similar. This would be the first node, so I need to do something similar as I did here. So actually, I could just copy this. So that is equal to new node. So that, yeah, that'll be fine. So I'll just double check this. So if self.tail, if I have a tail, then I put the next pointer to my new node, then my new node, the previous value to that old tail, and then I make the new tail my new node. If I don't have a tail, that means I don't have any value in the list. So I set the head to be that value, and I set the tail to be that value as well. The head. So do you want me to dry run this one as well?
Yeah, let's try run this as well.
Okay. So, or how do you do those? Was it like this?
Triple quotes.
Oh, okay. Okay. So here, I guess we'll do the 1, 2, 3 again. So if I want to add 1, originally there will be nothing in there. So I'll create the head equal to the 1, the tail equal to 1. Actually, maybe I should have value. I should keep track of the head and the tails as well. So originally these are both equal to none. Tail is equal to none. Okay. So now I want to add 1 at the tail. So what I'll do is I'll create the new one. And since there's no tail, none, I go into this other else block. And now I make the self.head is equal to this 1 and self.tail equal to self.head, which is 1. So the head and the tail will be 1, and the node will be 1. So now I go to 2. I want to add 2. There is a tail, so if self.tail 1 was a tail, we enter this first if block. If tail or self.tail.next. So you go to new node.
I think your function works. Let's add let's just write a test case for it here and then move on to the remove. I think the remove part is going to be interesting.
Okay. Add that tail. Okay, so it does work. Okay. Now the remove from head. So def remove from I just remove head. Actually, I can do this. Okay, so I want to remove from the head. Okay, so if there's no head, then I can just return myself. I had then I can return. There's nothing to remove here. So if there is a head, then I want to remove from the head. So what I need to do is, if I want to remove from the head, I need to keep track of what the new head will be. So I'll set, I want the new head to be equal to self.head.next. So that would be the new head. And then if that's the new head, then I wanted to also disconnect from the old head. So self.head, the previous will be equal to none. So now I've disconnected it from is it giving me? It's not okay. So I disconnected it from the old head,
Sure.
and then here I'll need to edit the head of the W linked list. So now I have self.head equal to new head. Oh, wait a minute. I need to account for the case if I'm deleting the last one and might need to edit the tail. So here, okay, if there's only this works for any node if it has more than 2 values. But if I'm deleting the last node, I'm also need to gonna account for the tail because I'll be deleting the tail as well. So if not, if there's nothing there, then it's supposed to equal to none. Okay. So stop the heads equal to this new head. If there's nothing, I need to account for the fact that I'll be deleting the tail as well. I think that's it.
New head equals
But not
self.head.next. Okay. Okay. I mean, is there anywhere? Let's see. Yeah, go ahead and try it out. Go ahead and test it. I think there could be a slight error here. I'll give try to look for it.
stop that head is equal to
Maybe,
this
maybe not.
new
It's not
head.
like a logic error, but it might throw exceptions.
Oh, yeah, the previous. Oh, okay. I see where there could be an issue here.
What?
So if there's nothing here, new head is equal to self.head.next. But if there's no next value, then I'm trying to access the previous element of a none. So that will give me an error here at this line. So what I need to do is new head is equal to self head dot next. So actually I need to just check if there's a new head here. So if not new head, so if there's not a new head, then self dot tail is equal to none. Then I'll just return it. Just double check this. So new head is equal to solver head dot next. If there's nothing there, I set the tail as well to be none, and I return. Else there is something there. So I set the previous value to be none. Oh, oops. The self dot head is equal to new head.
Okay. All right. Let's see. Try implementing it, or sorry, testing it, running it on some tests.
Okay. And, so I'll add in those values, and then I'll just try removing remove from head. I'll just call this twice. Okay. So it is working there. Let me try this again. Okay, it seems to be working. Let me test it when there's nothing
Or could you
in the
modify
list
remove
of
from head
intro.
to actually return the element that got removed, so we know?
Oh, okay. So that'll be equal to self.head.value. So this would be the value that we'll be removing right now, the head value. And then just run your self-details into the here we go, return. I can make this code a bit cleaner. But if there was a new head, then what I actually need to do is make this new head dot previous equal to none. And then actually no, I'll leave it the way it was. That's fine. So we could do just run it again. Oh, I need to print the values. Okay. So add 1, 2, 3, and then remove, remove. Mm,
Is it working? 1, 2. Move 1.
So
Let's try
maybe
this
this would be
instead.
better to test if I.
Let's see, this is an easier way to.
Okay.
There's an easy way to print it out. Give me a sec. Just so I could see it better too.
Okay.
DLL print list. Let's just say here every time. This. See how this looks. So add a tail. Or sorry, let's just print list at every single. Sorry, let me just. In between each one, we'll just print the list to just make sure we're doing everything as expected. So we add 1, we add 2, we add 3. Okay, we remove from head, we get 2. Okay. It's looking solid. Okay, implement. How would we insert into a random area? Like say we wanted to insert to a random index. How would you do that?
You want to insert to a random index
Yeah.
in the.
Write me a function that
Okay.
takes in an index or insert.
Okay.
Add a specific index and a value.
Okay. So I take an index and a value, and then I'll insert. Okay. So def insert at index. So index. So what I'll need to do is, if I want to insert at an index, that means I'll start off at the head. I guess I could start off at the tail as well, but I'll just start off at the head. And then suppose I want to insert, like, for example, the value is 2, then I'll need to move 1 ahead. So I'll need to, like, stay at the. Oh, when you mean index, is it 0 index or is it 1 index?
And zeroth index, like we're gonna be 0 index. So 0 puts at the head. 1 puts it
Okay.
at the first, like index 1.
So I'll just traverse the head until I get to the index where I need to insert it at. Then from there, I'll create the node. Then I'll put the previous index pointing, the next pointer pointing to that node. And I'll put that node's next pointer pointing to the node ahead of it.
I mean, go ahead and
And I
implement
need
it.
to
Let's
know.
see.
Okay. For here. So if I want to insert at an index, for example, the index is 2, then I need to go up 0, 1. So I need to go up 2 elements. So first, so it's index -1. I need to go up -1 elements. So parent, let's go to self head. Arrange, traverse, and just equal to, so I need to go up to the elements.
We could assume that index is always correct, as in we're not gonna try to insert outside.
Oh, okay. Okay. So my current element is going to be equal to current dot max here. Okay, so if the index is always correct, we go to self dot head. Okay. So now what is current dot next? The problem is that current dot next should be known. So if I have a head or if I have proper value, well, this value should always be true since the index will always be correct, right? But at the zeroth position, it's possible that there's nothing there. So if there's nothing there, then it's just inserting at the head. And we'll just, what is it? We'll just be adding that. Just be adding at the head. Self dot added head. This value. So we need to go ahead and create the value. Okay. So I'll handle the case if there was nothing there. We just need to add it at the head. Now, if there was something there, now we could go ahead and now add it into the list itself.
If not current,
Uh,
add it to the head. What do you mean by that?
so the current equal to will be the self dot head. If there's nothing at the head, that means we'll just be adding, we could just use the previous added head function to add it to the head. Uh, Maybe I should check for this here.
What if we did already loop through and we got to the end?
Sorry?
If not current. Yeah, I just don't get that
Be up
case.
there, actually. Um, like my current element, this would be will be the head for the list.
Okay, that makes more sense.
And if there's no head, then I should just put it here. I should have put this higher up. And then now I just loop through until I get to where I want to insert it into. And then while I'm there, then what I need to do is, okay. So I need to keep track of what was ahead of it. So ahead would be equal to current dot next. And the past value, if the past should be equal to current, that would be equal to current dot next. So this new node, all I do is maybe I should do the past first. Past dot next. This would be equal to the new node. So let's create this new node here. With the value. Okay. Now this past the next value will be equal to the new node. So that handles case going forward. And then now for this new node dot next.
Okay, we're pretty much at time, so I think we got to a good place. How do you think you did? How was that for you, that interview?
Uh, it's a bit weird coding and talking at the same time. Feels a lot different.
Not used
Not
to it,
used
huh?
to it.
Is your first time actually
Yeah.
having to do like code in front of someone?
Yeah, this is my first time.
Okay, I see.
Yeah,
Yeah, honestly, for your
this was
first
really
time, you did really good. You just, I think you just need to just come up with, or just follow a more clean approach when going through interviews, as in make sure that when you get the question, clarify first, clarify any assumptions. So you want to talk through,
okay.
clarify, just ask about the edge cases. So for example, for this question, if I first got it, I'll be like, okay, W linked list. Then I'll run some clarifications like what functions should I implement? Okay, if I'm trying to remove from the head and there's nothing, is throwing an exception fine. So just or and then what else? What are we gonna insert into the linked list? Is it just strings? Is it objects? Like, clarify first. Just make sure that you know everything about the question and there's nothing. You just clarified it. You did the due diligence. Does that make sense?
Okay.
And then after you clarified the question, you want to start ironing out your approach inside of the comments. So start talking about how you'll approach the question before you code and get alignment on that. So yeah, with this question, just mentioning, okay, we're gonna create a couple node classes, and I think this one is better. Sometimes this one is just pure coding, so you don't need to talk that much about it, but just ensuring that you have an approach before you get coding and making sure the interviewer understands that you're going the right direction.
Okay.
And then after that, after you clarify, after you mention your approach, then you start implementing it. And I think you did a good job implementing and explaining your thought process. And yeah, you were able to do a lot of the things right, like creating the node class, printing the list. Was you're able to catch some exceptions by just looking at the code without running it, such as the different null pointer exceptions. So I think you did pretty good. Just make sure that you follow a good process. Like you take the same steps every time you're going to do a question. Does that make sense?
Okay. Yeah, that makes sense.
Do you have any questions for me?
No, I think that's everything. Thank you.
Here, yeah,
Thanks
I'll
a lot.
send you a list of how you should actually approach these. But I think overall you did good.
Okay.
It's more just like getting these done faster. So being able to work faster,
Okay.
getting it done faster.
Okay.
But yeah. And look up, one thing I would look up is Sentinel nodes. Try to look up Sentinel nodes. It'll make your W link list way faster or way easier to write, especially when handling removing when the list is empty and you don't have to do this extra part of updating the tails and heads at the start.
Okay.
But yeah, look up Sentinel nodes. Have you heard of that before?
Is it like dummy
Yeah,
notes? I think
exactly.
these
So
are
if you put a if you come to the drawing here, if you put like a dummy head, like you create a dummy head and a dummy tail, right?
okay.
Are you in the drawing?
I think it's low. Oh, I
I'll
see it
show
now.
you.
Yeah.
Like if you create a dummy head and a dummy tail,
Yeah.
and then say we just have a variable saying that our list is size 0 and point in this. Every time you add to the head, all you need to do is you don't need to worry about no edge cases. You just add to the head like 1. And like all the inserts are the same, right?
Oh, and then okay.
And
I
then when you
we
keep
always
adding,
preserve these dummy.
yeah, and then the head and tail always stay the same. If you want to print out head, you just look at head to the previous. But every time you want to insert, you just keep inserting to the right of this head. So if I want to insert 2, and then every time I want to print out tail, I just print out tail dot previous if the value is greater than 0. But that way we don't have to ever keep maintaining who the head and tail is. We could just like the head
Okay.
and tail, the just it just makes it a lot simpler. You'll see when you try it. Try making sentinel nodes a head and tail sentinel node, and then defining these in the init function.
Okay.
Yeah, that's kind of my advice there. Otherwise, good job. Thanks for taking the time out.
Okay.
And I think you have another one
Thank
scheduled
you.
next week.
Yeah.
All right, we'll see how you do next week.
Okay.
Do something else.
I'll see you then.
Or is it next week or tomorrow? Let's see. Wait, you going tomorrow? All right.
Hey, let me check. I think I have one next.
I think
There's one tomorrow.
yeah, yeah. You booked one tomorrow.
Okay,
Okay, I'll catch you, man. All
I'll
right.
see you.
Good luck
Thank
to
you.
you. Got a job in touch grass. I love that. So you're just grinding out lead code, and then now you can finally touch grass. I've been touching grass a lot more often. Yeah, Jan, I'm ready. Yo, JN, what's up?
Yo, what's up? What's up? Can you hear me?
Yeah, what's up? What's up? Have you done an interview before?
I think no. I think no. With you,
Oh,
no.
that's crazy. Cause you've been on here for a while.
Yeah, we did a one resume review though.
Oh, really?
Yeah, yeah. You checked out my resume.
Where are you
And
based
actually, I
again?
applied. I'm in Poland.
Oh
Poland.
yeah, yeah. You're in Poland. Didn't you get interviews at like all the good companies in Poland?
I got, but like right now, I'm prepping for Waymo and Google.
Wow,
Uh,
that's so sick.
yeah, I got other ones, but my current company pays more, so I just.
Yeah. I mean, if your current company pays more, no point in. Yeah, I'll send you the link. Damn, you got a Waymo interview.
Yeah, I'm prepping for the Waymo one. Like super. Like I'm shaking actually. It's like 2 days.
Yeah,
They scheduled it, and now it's in 2 days, like in
dude, we
Monday.
got. Yeah.
Okay.
Okay, let me grab some water. Just join in. Join the chat.
Yeah, sure.
All right, we got JN.
Yo.
All right, hold up and start the video. Hey everyone, so today we're going to be prepping a candidate for Waymo. So Waymo interview in 2 days?
Yeah, it's gonna be in 2 days.
Dude, that's insane. So what have you been doing to practice for it?
Basically, I haven't been lead coding for like a 2 month, and then I just landed this interview, and they scheduled it really quick, so I had to like cram lead code for like a week. So I tried to cram as much as I can for now. Before that, I did like 250 lead code. So
Okay,
let's
so,
see how
so
it's
you're
gonna
at
go.
250?
Yeah.
Okay. So, I mean, I know people who work at Waymo, so I have an idea of the questions they like to ask. So how good are you with graph questions?
Uh, I don't know, to be honest, because I don't want to sound cocky and get cooked. So let's see.
All right. Okay. Let me get you a good question. So, all right, let's just hop straight into it. So, wait, how do you get this job? How do you even get this interview at Waymo? It's pretty hard to get into. Just reach
Oh,
out to
really?
you?
The recruiter reached out to me and said, "Hey,
Nice.
no position." So yeah, I think based in Poland, it's easier than in US probably to get interviews here. But yeah,
Yeah, what kind of where do you work right now?
I work at like top manufacturing company,
Nice.
uh, Warsaw, Poland based.
I see. Cool. All right. So the question, this is the first question. We'll work through 1 to 2 questions just to see where you're at. So
Okay.
we're gonna be given a network of n nodes labeled from 1 to n. You'll also be given a times which is a list of travel times between two specific nodes. So times I will show you the time it takes to get from UI to from node U to node V and how long.
Mm-hmm.
And pretty much, yeah, UI is the source node, VI is the target node, and WI is the time it takes for a signal to travel from that source to target. So we'll send a signal from a given node K, and you need to tell me the minimum time it takes for all of the nodes in the graph to receive the signal. So I'll give you some examples.
Oh, okay. So if it's impossible, return -1. Okay.
Yeah. Let's go in the. I think it does it make sense so far?
Yeah, I have a question.
Sure.
Can this, so the weight, right? It's gonna be always bigger than 0, right?
Yeah.
Okay.
They're always going to be positive. The weights are going to be positive.
Okay. So shall I hop into thinking process?
Yeah. Go ahead.
Okay, sure. First, we're given some node number. Okay. What I want to do is, first of all, I want to build the directions map where I will have for each node, let's say, or each node, the destination where it's going to and its weight. So I just want to store it for each node, all possible cases, so it will be easier for us to traverse through them. And after that, basically, we can just run Dijkstra's algorithm. We can just create a heap and put there the K starting node as a weight 0. And from there, keep appending whatever node is like goes through, traverses through. Actually, shall I go explain in drawing, or is it good for now?
We could explain it in drawing. It might be easier to chat to
Yeah,
visualize
sure.
too. Let's work through an easy example.
Yeah. Okay. New to this. Okay. Let's see. So we have these times thing. Okay. I need to make it smaller. Sorry. I don't know. Okay. So then we want to create a hash map for us to traverse through these. My hash map, because it takes the thing in all of one, right? So let's probably first. Oh, I can't move it. Sorry. So I have node 2, node 3, and node 4, right? Because I'm taking the first ones. Like, let's assume this is 2, right? This is, and this is 2 to 3. So this is 1. Let's say this is going here for 1.
Mm-hmm.
This is going here in 1. And 3 is going to 4 in 1 as well.
Mm-hmm.
And it's saying go from, was there a K2?
So these are single direction too, by the way.
Okay, yeah, sure. And then it says the return minimum time it takes for all the nodes to receive the signal. Okay, so my return should be the maximum amount of time. So I will go here first, because I'm gonna starting from this node, right? This is K.
Yep.
K. So I'm gonna create a heap, and I'll just keep appending. Actually, do I need heap here? Yes, I need, because I need to find the minimum time.
Yep.
And I'll append this first. So I'll append it because it has the smallest between those, no matter whichever will go. So we are here. We will traverse it through in 1. we save it as 1. As this node is not connected to anything, we go to the next node because this is the next smallest one. We appended this, and we check the destination. It takes 1 as well. And when we're here, we will see that there is one more node that's not explored. So we should keep track how much we had before. As it took 1 here, we will say, oh, how much it takes. It takes 1. So we just add it. And as we traverse through here, we'll have this node number, and it's this like how much time it took. So in the list of results, if we would be able to store this, it would be 1, 1, and 2.
Makes
we would
sense.
need to return 2. But
Okay.
I don't think we need to return all of it.
Pretend I had
We need
this. I'll show you. I'll show you one case.
Okay.
Pretend we had 4 here,
Mhm.
1 here, and 1 here. What's the answer?
4.
4? What about
Wait.
this is 4? Look, if we start at here,
Okay.
what's the answer? How long does it take for all the nodes to receive the signal?
4, because this is the maximum time,
Yeah.
no?
Okay. What about feels like this?
Then 5,
Mm-hmm. Makes sense.
because this is kind of a delay, right?
Yeah. What if I gave you this as a starting node?
Then it will return -1 because it won't go back, because there's no direction from 3
Okay.
to 2.
All right. I think you have a good grasp on what to do. Go ahead and implement.
Okay, cool. Um, okay. Shall I create the class, solution, etc.?
Yeah, exactly.
Okay.
Write out everything.
Let me wait a second. My screen is too big. I'm changing it, so don't mind me. 'Cause I was working on the big screen. Sorry. So first, I want to create the. First, I want to. Are we given those things? Like, can I just say times equals this, or shall I wrote it out myself?
Sorry, could you repeat that question?
Shall I put those things like here, or
Yeah,
is it gonna be like?
your function. You should create a function that takes in these inputs. Takes in a times, a n, and a k.
Okay, yeah, sure. Definition, traverse, or whatever. Oh, I need to train on those. So I need to take the time. Need to take n. I need to take k. Right. So okay. And then we can start. So first we want to do for source, target, and wait. In time. I want to say directions with hash map. Reference dot source equals to wait and target. I think no, I should append it and then create it as default. Take list. Cool. So this way we have all directions. Then I want to create a heap with 0 and starting node. Wait. Why do we need n? Mm,
What do we need to add? Yeah, guess we don't really need
yeah.
to.
Yeah, I
Well,
think what I want to do is like create a hash map where I'll have infinity values for each node, and then at the end, it will be easier for us to return the correct value. Because if we return the max, it's gonna give us infinity. That means that that node was not traversed at all, so it will return infinity. So we can return -1. Do I make sense?
yeah, makes sense. Yeah,
Yeah.
because
Okay.
we could
So
be given a tree with 10 nodes, but no edges between them. That should return false.
yeah, exactly. Um, so for I in range of n, I don't know how to code it in a better way, more cleaner way.
Mm-hmm.
Okay, as we have hash map this. Sorry. This I. Like this. Then I should make res k equals 0 as it's visited, right? As it's in the start. Okay, cool. Now I want to while h. I want to make it heap. Sorry, while heap. I want to pop the weight and the node. Equals heap q heap pop from the heap. How to import it? Okay. This. So I want to start from the. As we start from the k node, I put it in the heap as a 0 and k. So we pop it. Then we check whether. Let's just traverse first. Like, let's see what's gonna happen. I want to just flow with it for weight and for path, price and let's say price of the path. Oh no, for time and may in directions. No, right? I want to say new time equals time plus weight. So if res neighbor is bigger than new time, then res name equals new time and heap q heap push to the heap new time and neighbor, right?
If the
So
res.
this, so if res means results,
Mm-hmm.
and that neighbor is like bigger, and this new time is smaller, which is like optimal way, then replace that thing and push it. But if it's smaller already, don't traverse through that because we don't want to touch it, kind of stuff. And Dijkstra's algo would always ensure us that whatever is there is going to be 100% smallest pathway because we're choosing the smallest way all the time, right?
Mm-hmm.
Yeah. I guess that's it. Like,
Yeah. Okay, how do we get the result?
okay. So we return max. Actually, not to do it 2 times, max result equals max of res dot values, right? Um, return max result if max result is not equal to code infinity, else -1.
Nice. Let's see.
Mm.
Let's run this.
Okay.
Run this elite code. One sec. Give me a sec.
Sure.
What time is it over there?
It's like
Dude, you're pretty good.
11:30
PM?
p.m. Yes, I'm a bit like
Ooh.
yeah, I'm a bit. I don't code at this time actually.
Wait, give me a sec. Time. I mean, the code. Could you just quickly walk me through the code? It looks good to me. Just want to make sure.
Yeah, sure. So at first I'm creating directions hash map with a list where I'm gonna append all the possible ways node can traverse,
Mm-hmm.
putting their weight in the beginning of the this kind of packed value in order to determine which node to visit first. Because when we pop in the heap, it will compare the values in the first zipped value, which is like 0th index. That's why we're
Mm-hmm.
putting weight here, and then city or target where we want to go.
Mm-hmm.
And then we just take the result hash map to return the result. Put there for every node infinite value, because that will help us in the end to figure out whether we're like visited everything or not.
Mm-hmm.
Without this, I think it would be a bit complicated. And we're saying result k equals 0 because we're starting at k nodes. That means that it will take us 0 time to get there, right?
Yeah.
And then I'm putting into the heap the least value and starter, which is like 0k. And then while heap, I'm gonna keep popping the least value and check for that node that's being popped in the directions like map, which node I can visit, and there I'm calculating the time um by new time. Oh wait, time yeah new time is how much time it will take for us to get from start to direction node. And if that time is better than whatever is in the result, which is infinity at the beginning, we go there. We update the result as this is the guaranteed that this is going to be the least value. That's why we put it there. And then we push it to the heap with the new time and the neighbor that we're trying to visit.
Okay.
Then we keep
Makes
doing
sense.
it. Yeah.
Okay. Let's move into the second question.
Okay.
So this is gonna have some follow-ups.
All right.
So we're gonna be given an m by n matrix. Return true if the matrix is Toplitz. I don't know how to pronounce that, but it's pretty much if every diagonal from the top left to bottom right has the same elements.
Okay, I'm trying to imagine that. Okay, given a matrix MX, return true if it's every diagonal from top left to bottom right. So it's like a line, right? Has the same elements. Okay. So the question is actually kind of the understanding of this question is pretty simple. That's what I want to say. Is that so? If it's like this one, let's go to the drawing. So I will try to think there if it's okay. Where am I? I'm trying to understand it fully. So we're given a matrix, and if it's topless, if it's the left top is the same as, basically it's like a line to the bottom right side. This is the same. This is the same. And this is the same. Okay, I'm out of colors. These guys are same. And we'll have one values at the edges.
Okay, sorry. It's from top left to bottom right. It's a bit weird, but let me put the explanation here. So these are diagonals.
Wait, you're texting someone?
So 9,
5, 5.
5, 5. The diagonals are a bit weird. I was confused for a sec too.
Okay, yeah, so it's like top from. Okay, so it's this kind of diagonal, right? Okay, yeah, I got it.
Yeah, top left to bottom right. It's kind of weird. Why did it say top left?
From top left
Okay.
to bottom right. Okay, yeah. Let me think how we can do it. I'm thinking of just creating some greedy DFS kind of stuff. That will just not DFS, but more like some greedy iteration that will collect all of these values. So what should I return? I should return true if it's correct and false if it's not. Okay. So from my understanding in the second input, if this would be 1, then it would be true. Right? And we don't care about those two. Even if it's like this, it's correct. Right? That means that we don't care about the left bottom and right top. So we don't care about those guys. So we don't care about these guys. So what I'm thinking is to create some running algo that will just go. I'll have the boundaries of the matrix, so it will traverse from the beginning, bottom right, until it reaches the limitation. Same for the 2, same for the 3. And 4, it will reach the limits.
What do you mean by reach the limit?
Reach the, let's say, like I'm gonna put the boundaries. These blue are boundaries. Let's say this is left, this is right, where right is the like amount of columns possible, and left is the beginning, which is 0.
Mm-hmm.
And this is like index 4. So whenever it's gonna reach index 4, it's gonna say it's ended. So, but it will not able to traverse. But what I want to know is in this approach, if I'm gonna keep doing that. For example, when I approach at 1, we'll encounter limit here. How do I know whether it's... So I should return true probably, even if it will hit the limit. Let me check. Will I return true? What about this guy? It will return true. What about this guy? It will return true. So it will return true. Okay, but let's tweak it. Let's make it 3. Let's make it 3. I'm gonna traverse through this. It's gonna be okay. And when I'm traversing through the second one, I'm gonna go here. I will see that this is not correct. I will return false immediately. So in this approach, I think the brute force approach that I could think of is I'm just gonna brute force through the graph and like check whether the bottom right value is the same as this value. And if it's not, I'm just gonna break it and return false. If it's gonna reach the limits, it's still gonna be true. This is like the brute force approach that I could think of. I'm thinking, is there any like more smart or better way? Because I can see that these 3 values are repetitive. And
What's the time and space complexity?
For the brute force?
Yeah.
I think I would just need to store the previous value to check. So I don't think it's going to take any much of space. But as for the time complexity, I would have to run through whole list kind of stuff, like whole elements in the list, in the matrix. Sorry. So it's going to be all of 1, I guess. Yeah.
Oven, you said, or
Yes, because what I'm thinking is whenever we visit this guy, we want to put it into visited. Oh, I see. Okay, yeah. We want to put it into visited, and if it's visited already, we don't care about this value. Okay, so space complexity might be
what do we need
all
to
that.
visit it?
Okay, sorry. I was thinking to brute force it like this, and we want to check every possible value, right?
Yeah.
And what I thought is that we could optimize it by creating a visited and like mark there which guys we visited already, so we don't have to explore those, right? Do I make sense? For example,
Okay. Yeah. I mean,
we're here, yeah, and then here, because what I'm thinking is if we don't have that, we're gonna go here, here, and then assume that we check this value, this value, this value.
yeah. I mean,
Then,
okay. Go ahead and just try to implement. I think.
okay, yeah.
Yeah.
I think there's a better way of somewhat doing some mathematical calculation on this one.
What would be the mathematical?
I didn't see the pattern yet. I couldn't see the pattern. I'm like, I can see the pattern, but I need to think more on this, like how to make it better. So I think I'll just go with the brute force for now and see what we can do. But if time complexity is gonna be all one and space, at worst case, will be all one as well, kind of, almost. I think that would be. How do you think? Is that okay? Does that satisfy you, or
Yeah,
is there
sure.
any?
I think it works. Let's see how you implement it.
Okay, yeah, let's go. Okay, so class solution once again. Def traverse. Oh no, check is toilets, something like that. So we're gonna give them just matrix, right? And first I want to have I'm thinking which limits I should take focus on. The left boundary, the right boundary, we don't need top, but we need bottom. Okay. So I'm gonna say rows. Let me say bottom is the length of the matrix itself. Left is 0. Left is -1 actually. I don't think we need left. We need only right. Just length of matrix 0, whatever. Why are these gray?
Where? Because you didn't use it yet?
Okay.
Oh, yeah.
Okay, ID.
Active.
Okay, sorry.
Okay.
Sorry. Okay. Then we want to go just to loop through it, I guess. So I just call my function. I don't know. Traverse. So I'm gonna be given row and column. So what I want to do is for let me get this guy somewhere here for me to think. So we're at here. Okay. We want to check if row equal to bottom or column equal to right. Then return true. Keep it true. Let's see. Mm-hmm. I know I have those, but yeah, I just want to make the loop easier.
Okay, I'm wondering why we need a visited set.
Because I want to kind of if we traverse through the first row, right? I'm going back to the drawing board. What I'm thinking is like if we're going through every element in the matrix here, right? So we visited only this guy, this guy, this guy, and then this eventually, and then these two, and we hit the limits. As for the 4, it's gonna be just this, and then I want to know which ones I didn't visit it. If this graph would be bigger, something like that. I don't know, some X, Y.
So we're gonna try to traverse the matrix row by row, but then compare.
But per element to element, like this. So if I'm visited this, I'll just skip it. If I visited this, I'll just skip it. If I visited this, I'll just skip it. So it's gonna
Okay.
go element by element like this, right? And then I'm gonna check those, remove those
Okay.
two.
Go ahead and implement.
Okay, cool. Okay, cool. Range of rows. Range of calls. I know that this is a very naive approach, but if row call is not in visited, don't need this here, not in visited. Then we just do traverse row call. But we're adding it here. It's okay. Does it matter? Does it matter where I write the function? I don't think so. Why is it saying error? It's,
Well, cause it right
uh,
doesn't. If you are you seeing it? It's hover when you hover.
oh yeah, it's good. No, I don't see anything. Okay, so okay, um, okay, this is good now. So I'm gonna
It's
add
not
that
syntax highlighting for you.
it's highlighting, but it's weird. I think it's my browser having some issues.
Interesting.
Uh, yeah, I use like old version. I have one extension, that's why. Okay, not important. Visit it, we add it, then we go check the next direction, which is um, next row and next column is row plus one, column plus one, right? And we check if new row is less than right. But if we do this, it's not needed. But let's see, let's see. Bottom and new column is less than right. Mhm. And then we need a then we need the value itself. I don't know, right? And we'd have to check and if and matrix new row new C. Okay, I'm thinking. Is equal to value, and it should traverse. Should traverse by the value itself. Mm, thinking if the next element is not equal to value, I want to break early. False. If it's okay, then it should go. If new row is until bottom and new column is until right, it should go and it should check if the next if you have this, we don't need this guy anymore. And then it will traverse and it will return true. I'm really skeptical about this implementation, but
What are you skeptical about?
there might be some edge case that I don't know that I'm not catching. I think this is very naive, but I do assume that it shall work. Uh,
Okay, can
oh
you
wait,
walk me through the code?
um, wait, I forgot one thing. Visited at. If it's in visited, I shall just continue.
Continue.
I should just
Traverse should return a bool.
yeah, it return a true boolean. Yeah, it should return just whatever the value it was there, which is true because it will break by false if it's bad here logically. And I don't need to put it here because if I'll add it and visit it early, it will just return true. And this is ensures that it's gonna keep added, so I don't need this visited. I can go like line by line if it's okay now.
Run it on a couple examples. Or
Um,
let me ask this follow up.
sure.
I want you to parallelize the implementation, as in,
Oof. Okay.
yeah.
Uh,
Can you parallelize this implementation? Is it possible with the way you did it?
uh, I think I think yes, but I'm not sure. By parallelizing, I need to implement the syntax of parallelizing in Python, right?
Or
It should
let's
take.
just talk through it. Like how would you parallelize this? Parallelize. I don't know if I'm saying it wrong. Parallelize.
Yeah,
It's a tongue twister.
parallelize.
How
Yeah.
do you make how do you make it run in parallel? Is it possible?
Yeah,
Like
because as you can
pretend we have a
see,
function that could spin up multiple threads, right? So, like in Python, it's usually single threaded, but pretend it will actually do it in separate threads. So, like,
if it's
would it
in
make it
if it's in,
faster?
if it make it fast, it's not gonna make it faster. But we would need to remove the visited guy. Oh no, it's not. It should stay. It should stay. Sorry, it should stay. But we're gonna just pass in each element on the list as a parallel, like one. So pretend we have 4 nodes. We just assign every node one element in the list. So we're just gonna loop through like this, and it's gonna run everything in parallel.
So
So
each
meanwhile,
thread is gonna run on a specific node. So, but then these are gonna do double work. So we're gonna have way too many threads.
no, not in each node, but like in the first row nodes,
Mm.
and and I think there should be okay for each node on the top, and every first uh, every first element in the following up row. So this way we will catch the new diagonals, right? So we're gonna keep. Uh, so pretend yes. So if there was been more elements, like if the list is gonna be grow bigger, 9 would have more values on the bottom to check, and if there's gonna be 10, 10 will have more values to check on the bottom left. So I think we would keep adding. Oh, sorry, what I did. I would keep add the next element on the next first element in the next row to the thread until we reach the bottom. On the bottom one, I wouldn't add because it's always going to be true. What about the last element in the first row? It's going to be always true because it's limited by the limits. So I would just run these and this, right?
Okay.
Does that make
So
sense?
so you're gonna spin up a separate thread for each diagonal.
For for each diagonal, yeah, that's a good one. That's a good word. Um, so yeah, and I think I can calculate how many threads I would need for a matrix because it's gonna be number of rows almost, and
Yeah.
first number of elements in the first row. So
Okay.
does that make sense?
Yeah. All right. I think we're pretty much at time. How do you think you did? How was that for you?
I don't know, James. I think I fumbled on the second question.
Yeah.
Pretty hard. I know this question. I saw this question somewhere, but I didn't solve it. As for the first one, I think that was a warm up, I guess.
Yeah.
I think I did like pretty. I could do my way better in the second question.
Yeah. I mean, the first question is supposed to be way harder than the second question.
Really.
The first question is a medium, second one is easy. So the
Because the follow up question about parallelizing should make it hard, right?
it'll make it harder. But okay,
Uh,
let's just walk through the first one. So the first one, I think the first one is a medium. A lot of people won't really solve it. A lot of people can't solve this question. I've seen it get asked because most of the time it's just because they don't know Dijkstra's and haven't implemented Dijkstra's. So if you haven't implemented Dijkstra's or don't even know about Dijkstra's, you're gonna automatically fail the first question. But clearly, you knew Dijkstra's. You were able to figure out the approach. The code looked super clean, worked perfectly. Didn't need to look anything up, any of the syntax. You knew how to do the imports. Um, yeah, and you caught all the edge cases, as in if we don't traverse all the nodes, if one of them is infinity. I think the code there was perfect. So you kind of executed on question one perfectly,
okay.
even though it's a harder question. But yeah, in the second question, you just overly complicated the question way too much. So essentially, what it's asking is we just need to ensure that all diagonals have the same elements. So 9, 5, 5, 1, 1, 1, 2, 2, 2.
Mm-hmm. Yeah.
So you could pretty much just create a subroutine that takes in a row and a column and then traverses diagonally, as in adds +1 and adds +1 to the row and column, and then just tries to go down until it's out of bounds of the matrix and just ensures that as it's moving down diagonally,
Uh-huh.
all the values are the same.
Yeah, so basically the same thing that I did, but with for loop.
And you
Right.
you created this visited,
Yeah,
which you're looking at each element more than once.
I see.
Which, yeah. So
Okay. How?
and you
Okay.
can't parallelize it when you're using this visited. So the solution is you make a subroutine that takes a row and a column and maybe a value, and then that subroutine just works on that specific diagonal, as in it just traverses that diagonal and just ensures that diagonal has all the same values. And to parallelize it, you just make a thread for each diagonal. Each thread handles one diagonal, and then you join the result, and if any of them are false, it's false.
Yeah, I thought the same because in the thread you can't use like any space, right? Like you can actually use in some modern Databricks clusters, but if you think about threads, it should be without space. Yeah.
What do you mean without
So
space?
like visited would be you should do this without visited. So yeah. If I'm gonna use visited here, you cannot run in parallel. This guy.
Just using shared state.
Yes, yes, yes.
Each thread needs to maintain its own state. Like
Mm-hmm.
they could share the same matrix, but none of them are updating the matrix, so it's pretty much a read only. So that's really fine. Um,
Mm.
yeah.
Yeah.
So I think yeah, you kind of overcomplicate the question. There's no real math solution to this because you need to look at every single element. So because like pretend you don't look at one element. How are you sure that that one element that you didn't look at is going to break, or it is going to be the mismatch in that diagonal?
Yeah. By math, I meant like not like just return, but more like the way I do the loop can be just in a math way. Like
I
row
see.
plus one, a column plus one,
Yeah.
and then just keep adding. Yeah, and just check something like that. I knew that this is way simpler
Yeah.
because what I'm doing is just one bottom, one right,
I'll
one
send you the
bottom.
question. Yeah, go try out the question. Take a look at it when you're not tired, and you'll probably be able to solve it faster. But yeah, this is a common Waymo question too. Is be able to solve it really fast, and then this follow up would be to paralyze it, as in
Oh, and I have
run
to
the
code the
threads.
parallelization.
I'm not sure. I just seen it being asked on
Okay.
GitHub. People say they got asked that on LeetCode, and then yeah,
Oh,
Otherwise, yeah, the code is pretty clean. I think you just super overcomplicated it. So really take a step back and think if there's a simpler solution.
Yeah, I think
I
yeah,
mean, your solution works, but you would just not be able to parallelize it at all.
yeah. Then if it's gonna be follow up, I'm cooked, kind of.
Yeah. But
Okay,
yeah.
how cooked I am from out of 10?
No, I think you're good. It's just I don't know what happened with this question. But you
Yeah, I
obviously
think
coded, but you took a while because I think the question is simply saying just make sure every diagonal has the same values, right? So what the
yeah,
moment it's telling you to compare or is just check diagonals, the first thing that would come to my head is just loop through it
rope.
or just loop through the diagonals, but you wanted to loop through it row by row, column by column like a regular matrix. So that's why it complicated things a lot. So I wasn't sure why you're deciding to do that.
Yeah, because I
But
want to do element by element, and then
yeah.
yes, and then just take everything that I visited into visited set. What I thought is like how I'm gonna catch the first element in the row, and then I said to myself, I can just loop through it. Okay, yeah. So okay, yeah, I just overcooked myself, I guess.
Yeah. And then you try to talk about some optimizations like ignoring the last element in the first
Hmm.
column in the last element in the first row. But that's just super small optimization. I wouldn't write that
Care.
because yeah, it's just gonna run once anyway. So if you have to add an edge case, you just add complexity
Hmm.
to capture that. I don't. I would just yeah. I wouldn't do anything there. Add extra code for that.
All right. What
Yeah.
about my like kicking in explanation like initially? Like, uh, did you lost me until I draw everything?
No, I think explanation is fine. It's just coming up with the approach, but everything else is good. Like you're able to write clean code, and yeah, I have no problems reading your code, and the way that you conduct your interviews is perfect. It's just yeah, just make sure that you can come up with the simplest answer. That's pretty much
Yeah.
it.
Okay.
But I think
Oh,
overall, the first question is a hard question. You were able to solve it.
yeah. Yeah. I was glad. I was so happy that the graph was like only positive
Hmm.
values. Because if it's not, then it's like
Yeah,
too
maybe
stressful.
that's a follow up. But all right, I gotta hop on to the next person. Thanks for taking the time out.
Yeah. Thank you, James, for
All right,
what you're doing. Yeah.
no
See you, bro.
problem. See ya.
Bye.
Hey, what's up, man? What's up? What's
Yo,
up?
what's
How,
up, bro?
how you doing?
Doing good, doing good, doing good.
You at a coffee shop?
Oh yeah, yeah. I went to a festival all day, so
Nice. Wait, I can't hear you too well. It's a little low.
dude, come on, man.
Can you hear me?
Uh,
Is my audio
yeah,
good?
of course. Yeah.
Okay, wait, let me see. Is there a way to make your audio a little bit louder? And then we're good.
I'm using an AirPod. Better?
Yeah,
Really?
kind of. I don't know. Whatever. We'll just roll with it. All right, man. Do you want to introduce yourself?
Hey, so I basically self-taught and I've been interviewing a lot, and I haven't been able to pass assessment, so I'm just hopping in, get some action for fun, you know.
Yeah. Have you done any of these interviews before? Like any of my coding interviews?
Honestly, no. Honestly, no.
Okay. So you're
Uh,
you're
I'm
actually
pretty
getting interviews at what kind of companies?
like Apple, XAI,
Ooh.
all the company, and their assessment is like insanely hard, like 1 hour, three lead code, medium, whatsoever. That's like insane.
So they're all asking you leak code specific questions?
For the assessment, yeah, I can really never pass the assessment. I actually
Yeah.
just interview like last Friday with a YC combinator or whatever, one of the
Yeah.
startup, and they gave me like 20 minutes for 2 questions, and the second question is like after I look up the solution, it's like 50 lines of code. It's a joke.
So they gave you 40 minutes for 2 questions?
No, actually, yeah. So first question is somewhat easy with hash map and sorting.
Yep.
And the second question is like a bunch of string array. And then like, so, it's like 3 different property in one string. And there's an array of bunch of strings. And then you have to like sort them out and print out whatever. It's like 50 lines of code.
I see. So
Yeah.
so from your experience, companies are still asking leak code? It's still something you need
Yeah,
to know?
every time, so there's only there's only 2 interviews where I did where they just gave me like take home assignments where they like it's actually a joke too. So basically what they did is they give me 1 hour and I have to email them back the whole project within 1 hour.
Yeah.
And they want so it was a Swift UI interview and they want me to build one of the contact list on your iPhone within 1 hour, and they give you like all these little specific everything. Even AI
Yeah.
can't even do it. It's a joke.
That's crazy.
Yeah. But it's okay. But it's not that bad. But I only just started coding like exactly 2 years ago. So
And
I know,
you're
like, people-
self-taught?
yeah, I know people grind for like since high school and master whatever.
That's
So
crazy.
I'm,
No, like
I'm kind of a beginner.
that's insane. You're self-taught and you're getting interviews at XAI,
Well-
Apple.
I mean, if you go to XR right now and you apply for the AI tutor role. So AI tutor, basically, you'd have to know how to code. Though they ask you for so much. I think they just vet you out with the assessment. It's not even real interview with people. It's just like assessment.
I see.
So but XI is pretty nice to me. Like I emailed them back and forth, and
Yeah.
they said like if I pass the assessment, then I get to be on an interview with a real person, whatever.
So you
And then
started coding 2 years ago. You're a self-taught dev, and you're trying to just work at YC companies, fan companies, or whatever you can get opportunity.
Yeah. Currently, I'm working at not working. I mean, kind of get a little equity on a trial thing with like a tennis startup that's play tennis.
Mm.
So sorry. So I play tennis and sport. So when I built my resume is not too bad because like I built like mobile application that have like users and stuff for tennis. You know, that's kind of my advantage.
Yeah.
So because I have pretty good apps on the app stores and stuff, I think that's like how I get interviews.
Mm.
Yeah, because like my background's in tennis, and then I have some like big community of tennis people. So like, if I just build like a good looking app, whatever, and I tell my community to like help me out, and it's kind of good, you know. But that's what I'm doing. Just making myself look good. But like when it comes to coding, can't code.
Yeah. All right. I sent you the the coder pad link. Let's just get into some questions. How good are you at LeetCode?
Honestly, I solve about 100, but I mean, I don't know if that really is solving. It's more like somewhat looking up solution with ChatGPT. How do I do this? Enter my name and enter my email, and then click join as a candidate. All right, let's go, man. Ready. Python?
Are you in?
Yeah, I'm in.
Okay. Let me. I have a good question. Give me a sec.
Yeah. So, are you still working as a software engineer, or you just like doing the YouTube thing now?
No, I still work software eng. I barely do this YouTube.
Oh, that's pretty cool. Where at?
Meta?
Oh, that's pretty cool. No way.
Mm.
Do you have to do lead code to get in?
Yeah.
Dang, how long do you spend like lead code? Like a year or like what?
How long have I spent doing lead code?
Yeah.
I've done 650 questions.
Are you serious? 600? Get out of here. How do you even enjoy that? That's so painful.
How do I do 650 questions? Did
Yeah.
I did it over the span of probably like 5 years. So, I mean,
Oh,
100
yeah,
yeah,
yeah.
it's like I
Oh,
already went
yeah.
through 3 or 4 recruiting seasons. So I went through recruiting season for internships. Then when I hired as a new grad, then when I switched companies, and then when I switched to Meta because I switched companies. So I switched companies twice now, and like had to study for internships and new grad. So it's between all of those, and then now this YouTube.
Oh, that's pretty
So
cool.
it's not like I
I don't
just
see
did it all in
anything.
one go.
Oh, okay. Yeah,
All
this is
right.
like my first time. Yeah.
So I want you to create me a stack class with these operations.
Oh, okay. I like this question. I'm not gonna lie. This kind of question is like a lot better. Create you a stack with these operation push pop keep is empty. Okay.
You studying from a coffee shop?
Oh no. Usually I'm at home because like it's Saturday. There's like a festival to hang out with my friends. So that's
Ooh,
why I'm out here in a coffee
nice.
shop. I barely made it on time though.
No problem. So what are you thinking for this question?
Dude, so for this question immediately in my head, I'm gonna create like a class, right? And honestly, I don't do a lot of Python, you know, but I think Python. I mean,
What language do you want to
I
use
can.
then?
You know what? What's that word? We're just gonna raw dog with Python and see what happens.
I mean,
So
use the language that you're most familiar with.
okay. Honestly, let me try Python. Let me try Python.
Sure.
Uh, okay, fuck it. Sorry. Where can I change my language? Which language?
What language do you want to use?
Uh,
Swift?
oh my gosh. Okay.
This is the first.
I might have to. I'm nervous. Swift. I've been coding in like JavaScript, Swift. I got confused. It's all over the place, but the only thing that matters nowadays is the actual logic. All right, let me just. So you definitely want to do a class. Let's call it stack. Stack problem, whatever. Struct. And then you definitely want to have this, right? And obviously Swift's gonna want type. So you have to have a function, right? What's the first function? You have push. Basically, what that is you push an in into the back of the stack, and I assume the x is gonna be an in. So I think you have to do self stack dot append. Now here's the tricky part. Tricky part here, I'm suspicious. I have to do some like edge cases or whatever where like do I check for like hello, are you still there?
Yeah, I'm still here. I'm listening. Can you hear me?
I'm worried that it's not gonna be this straightforward. I have to do some type of like checking if the X is already like if it's already freaking. I'll worry about it later. But I think
I
if
mean,
you
what are
guys
you
just
worried
gonna
about?
push, I'm worried about like if you do just like self.stack the append X. It can't be that simple, right? You have to check for like an if X already exists, something like that. But I'm not gonna worry about that right now.
I mean, why would it matter if it already exists?
That's the right question. Probably doesn't matter. Anyway, I'm gonna move on to the next function. Let's do a pop. So when you do a pop, I think what you do is you go self.stack remove first. Ooh, but and then I have to return it, right? I think with Swift, what happened is when you do remove first, I don't remember exactly, but it's return optional. You have to like, okay, how about this? If let pop in equal from here return pop in. Now I think you have to do this with Swift. Why can't I use let here? Initialize a conditional binding. Initial therefore. Maybe I'm overcomplicating thing. I can just do this. Remove, return, pop in. Right? That's a better. Okay. Kind of nervous. Okay, move on to peak. What is peak? Return top element without removing it. What's that mean? To return the very last, right? Am I right? Return the latest, right?
Yeah, return the top element without removing it. Don't. It's like it's similar to pop, but don't remove it. Just tell me who's at the top of the stack.
Yeah. So basically, when you append it, the last you return, you want. I get it. So basically, just like pop, but don't remove it. So how do I do that? Oh, it can't be that hard. I mean, you just call var let peak in. Sorry, bad naming. Called self.stack. -1 would this work? And return peak in. I think that's it. I think that's pretty much it. No, let me think without. So you basically want the very last element of an array. So you can just do -1. Yeah, screw it. I think I'm correct. I was thinking something about like dot blank something. Is empty. Fun is empty. Return whether the stack is empty. So it's probably gonna be Boolean. So if Garlet, I think if you use Garlet, sorry. Garlet is just call it empty. No. Garlet. I'm just pseudo coding, but it's probably something like this. It's because I know Swift have a function where you basically write .em is empty, return. So yeah, so I think my logic is correct. Basically, if you can't really garlet, huh? Why can't I just use if to make it simple? If. There we go. If. What do you think? What do you think? Can I test it? Can I test it? Or
Yeah, run some tests.
Like this? Ew. Five. Print. Dude, I'm nervous. Learn.
Can you push?
Oh. No, I can't. I have to be so sorry. Learn. Hey, it's working. It's working, buddy. Let's go. Okay, what's the next thing we should test? Pop?
I mean, push a bunch of stuff onto it.
How? So basically do this. Yeah?
Sure.
There we go, there we go. Not too bad. Sorry. This is confusing me. If stack is empty. If it's not empty, then return false. Am I right? Why am my brain not working? If stack
Can we
is
try to
empty-
push a bunch of different elements instead of just fives? Just to
Yeah,
make
I
sure.
got you. There we go. Whoa. Yeah. So it's put at the end of the array. So we put push no. Yeah, it's kind of good, no? Oh, test R dot is empty. Can I print this? Can I put it in a print? Oh, there we go. It's working. It's working. Let's work on that. Whoa. Okay, so is empties working? Switch working? Let's see if pop is working. Yeah. Let's see if pop working. So what did I do? I'm gonna test R dot pop. Boom. Ooh, something's wrong. What's wrong? Remove first. Pop is unused. Result warning, result of call to pop is unused. Why? Why is it not working?
Try to debug the pop.
What do you mean by unused? I'm using it right here. Self.stack, remove first.
So what's happening? What's
Wait,
the
wait,
issue
wait,
here
wait,
when you
wait.
call pop?
Wait, sorry, remove. Dude, it should be remove last. Remove last for sure. It's not remove first, my bad. Yeah, that's not gonna fix the problem. They say unused. What do you mean by unused? So basically, I think I have to do this. I have to do this. I have to do print. Maybe. Come on. There we go. It's working. Let's go. This is insane. Okay, are you happy? You happy with the push and pop?
Yeah, I'm happy with the push and pop.
Let's go. Okay, so push and pop. What about is empty? Is empty? You gotta be happy with that. Is it working? Is empty working? Right? You want me to show you again?
Okay, what if we just call pop like 10 times?
Okay, so is empty is working. Okay, so let's mess with the pop. Okay, so you want me to 1, 2, 3, 4, 5. We're gonna do 6. Okay, 1, 2, 4, 5, 6. Let's see the error. Yeah. Yeah, there's gonna error. So you're right. This is why I'm a little bit inexperienced. So if self.stack is empty, right? You're gonna print stack is empty, can pop, then you're gonna return it. Now when you run again, oh shoot, return 0. I have to return 0.
We have to return 0? Is that what I said?
Because like, oh yeah. So how do I do this? You know what? So why is it crashing? It has something to do with this little block right here. I think with this little block right here because in Swift you have to return something. But you return pop in right here though. Maybe use Garlet. No, it doesn't work.
What's happening?
So if I don't, I'm just debugging. Sorry. Okay. So if I return 0, right, it's working. You see that? There's no errors, right?
Sure.
So my logic is, I think it's correct. It's just the syntax I'm confusing, you know? Because because the function is saying, you know what? What about if I do this? What if I do this, and I don't return anything here? Oh, it doesn't work. Why? Come on. So what if I use if let? I can't use if let. You know what? What if I use else and just do this?
Well, once you
You're
return
saying-
an int, so I mean, you could return an int if you want.
Yeah.
I mean, there's two ways to handle it. I mean, just return something or throw an exception.
Yeah. So you think you like this though?
Yeah, I mean, it's not bad. Let's see.
Yeah. But so it's kind of work. Right? It's kind of work.
Yeah.
Can we move on to peak? Can we move on to peak now?
Yeah, go ahead and. I mean, you already you implemented it, right? Peak. Yeah, go and test it.
No, I haven't. Yeah, but I haven't passed the peak thing. So theoretically speaking, when I do peak, I should get one, right? Wait. What do you mean by top without removing it? So I should get number. Yeah, I think I should get number one. So I'm gonna uh sr dot peak and um and I want to print it out to make sure that I didn't remove the number one. Number one should still be there, you know? Dude, what's up? Come on, man. Come on. Bro.
What's happening? You tried to peek, and then what? What is it saying? What's...
It's saying index out of range. I'm familiar with that error, of course.
Because you're trying to grab -1.
What is -1?
I don't know what
Oh,
-1
wait,
is.
wait. I got this. So, this is easy though. This is easy. I think dude, I can just do length -1, right? Stats.
How do you grab the last element in an array in Swift? You chose the language. You should just make. You should be familiar with like the common array functions, but call it your stack. This is the length. Has no member length.
Oh, it's count. It's called count. Yeah. I swear I didn't Google that at all. One, it
Okay.
worked. Yeah, it's called count. There has to be a function for that though, but in JavaScript probably the same thing, huh? Yeah, so JavaScript use length.
Okay. It's looking solid. Take a look at that peak function and let me know if there's any edge cases where it might break.
Oh, okay. Why is it giving me an error here though? Result pops unused. Pass that R at pop. What do you mean unused, man? I used it.
Oh, don't worry about that. I'm looking at peak.
I used
34.
it, right? Oh, okay.
Observe the peak function and let me know if there's any issues that could occur in this peak function.
Obviously, I'm a pro. I got this. Same thing right here. I'm a pro. You can't peek an empty array, you know?
Yeah.
Can't peek, buddy. There we go.
Okay, how would you test that?
How I test that? I basically there we go. I just test that.
Okay.
Right. What do you think?
Yeah. Okay. All right. Wait, give me a sec. We're gonna go to. I want you to implement one last function.
Okay, one last function. Okay.
I want you to implement a function called get the minimum, which retrieves the minimum element in the stack.
Okay, I got you. So func get min. And then obviously you want it to an in, right? It has to be an in. So obviously I have to do the same thing here. And then obviously I have to do the same thing here. And then but return. How do I do a min? There has to be a function for me to do a min. Var min equal sub dot stack dot minimum. Does this return? Dude, I absolutely raw dogged this. I didn't know Swift actually have a min. But I know Python does. SR dot push 5, and then I'm gonna do 3. And technically speaking, when I call it should give me a 2, right? I'm gonna move this up here. Please work. No error. Yeah, it's working.
All right. So let's go top to bottom. Tell me the time and space complexity. What's the time complexity for this line 18, this push?
That should be linear O of 1, because no matter how big the array is, the time that it takes you to push is gonna be the same.
Okay.
The space obviously gonna be linear, right? Because the more you push, the more array is gonna be.
Okay. What about the pop?
Not the same thing, exactly. Because you remove the last, so no matter if like the array is bigger or smaller, it's the same thing. Space, yeah, I think space should be O of 1 too.
Okay. What about
The
peak?
peak. The
For just
peak,
time, I don't care about the space actually.
Same thing, same thing. You're always gonna look at the very last. We look at the memory of the thing.
Okay.
So the way it's retrieved the last one using hash whatever. So
Okay.
it's gonna
Is
look
there
at the
any
last
way to
thing.
clean up this is empty function?
Anyway, to clean up the is empty. What do you mean by that? It's you just
Take
okay.
take a look at that and see
alright.
if you can clean it up.
Like one liner.
Possibly.
So you just basically return back. Dude, it's still loud, noisy there. Sorry. Basically it. No.
So why are you flipping it?
What do you mean by I flipped it?
Why'd you put a
Oh
knot?
yeah. Oh yeah, that's just habit from coding the
Okay.
UI whatever.
Yeah.
Sorry.
Okay. What's your time complexity for get minimum?
I think that is, since I don't understand the min thing right here. I understand what like the actual algorithm is at min, but I would definitely think that it should be O of n, because like obviously the longer when you look at the array, you have to like traverse and look for the compare one by each one, so it has to be a linear, you know. I mean a constant, no. Wait, yeah, linear, O of n. Yeah,
Linear? Okay.
yeah.
So every time you call get minimum, it takes O of n time to find the minimum? Is that what you're saying?
Yeah, I think so. I mean, yeah.
All right. How can you make that faster? I want this get minimum to be O of 1.
Ooh, okay. Maybe now we have to use like a linked list or something, you know, where we have a pointer, you know, where we have like object and pointer, or to use like we have to sort it. How do I? Ooh, let's think about this. Let's think about it this way. How can we get this to have an O of 1 time? That's a good question. So, oh, I know. Oh, maybe. So, how about this? Theoretically speaking, the moment when you call min, when you call min, it should it should, if we sort it, right? If we sort it, and it just return the very first element in the array. But when we sort it, then we would have to you have to think about like the time complexity of sorting,
Yeah.
right? So sorting is a no go, right?
Yeah. I mean, sorting is usually n log n time. So that's
So it
slower than
can't sort.
just that's slower than just your current OVAN operation. Current OVAN.
So so say yes or no. Give me a hint. Big list. No.
No.
Dude, how can you get the min? How can you get the min of one? Like how? So you can't. So how?
Okay.
Oh yeah. I might have something. So you cannot use min. You cannot use the built-in Swift. You know, you have to build something of your own. Am I right?
Yeah. Yeah. You have to figure out the min in a different way. You can't just use this min.
Ooh. So how can I use my own min? Oh, I might have an idea. Let me cook. So you store a var min equal negative infinity, okay? In dot min something in Swift, and then we run for I in self dot stack if freaking I is less than min equal I, and then we do something with like the max dot min of min and I, something like that. Am I in the right direction? Oh no.
What are you trying to do here? You're trying to find the min. You're trying to implement your own min. Well, now you're looping through the stack again.
Yeah, so looping is a no go.
Well, looping is OVAN, right? We're trying to get it to O1.
Give me a hint. Why do you even start?
So the small hint that I'll give you is that is there a way that while we're inserting, we can figure
Okay,
out
so it's
like, yeah,
it's not even to do with this function.
yeah, it's
We
like
have
we
to
need
like
to
trace
be able to
back.
figure it out, or we need to
Oh,
maintain some
okay.
other way of knowing the minimum, and then we just need to refer
So
to it. So it's you can't do all the work in just that one function.
yes, that thank you. That was very helpful. Thank you. That was kind of I suspect of that solution too. So it's just, you know what? So let's go to push, right? So tell me if I'm on the right path. So every time you push in a new number, you have to keep track of the minimum number, right? Am I right?
Sure.
Minimum. What? So let's call it freaking. I have to do like 0, and then when I put a pen here, if uh, if x is less than minimum equal x, now we basically have a self. We have like a placeholder variable, and then every time that we push, we keep track of that immediately, right? And from here, we basically just return. So instead of this, we just return self.min. What do you think?
I mean, it makes some better progress, but what if we're popping and we pop out the minimum number?
What if we pop it? We pop at the minimum number. What? what if you popped it and you popped at the minimum number?
Okay, pretend. Come to the bottom.
Okay.
Pretend we add 1. We add 0. We add -1. Right? Then
Yeah.
we call min. Get min. That should return -1, right?
Yeah, yeah.
Okay, what happens if I pop?
So if you pop, it's no longer in the array. So if you call get min again, it should be 0.
Yeah.
Theoretically speaking, right?
Yeah, exactly. So yours won't, like if I call pop, yours won't update properly. Like yours will still
Yeah,
return
that's
-1.
oh, because okay, I understand the freaking problem now. But how do I solve it? You know what? How about if uh how about how do I solve this? I can't. I mean, I can't.
Yeah.
I can basically when I popped it, I compare it. I compare if
I mean, yeah, we're pretty much at time, so wanted to just stop it there. How do you think
yeah,
you
yeah,
did?
that's a good place to start.
How's that for you?
I think I did to my level. Honestly, this is like my level. That's a good question to give to me. If you ask like matrices and stuff like that, there's no way.
Okay.
Yeah,
I
this
think
is like my current level.
yeah, I think definitely you should just be more familiar with the language, as in when you
Yeah,
pick a
yeah,
language, you should be able to pick a language you're familiar with, because it seemed like you're trying to figure out a lot of the language stuff at the same time you're writing the code. So you should know with the language you're using how to create a class, how to create a variable, which you did. But then
yeah.
all of the common functions when it comes to the basic data structures like arrays, dictionaries, whatever, you should know the basic operations. So know how to get the size of an array, know how to grab the first number, the last number, know how to insert, know how to pop, remove, know how to operate with um, like empty arrays. Just you need to know the language that you're using inside and out, and not get stuck on small language specific stuff. So yeah, what I would do is
Yeah,
just make sure to memorize and pick a language that you're actually comfortable with. So if you're not comfortable with Swift, I would just spend more time practicing Swift.
yeah. Cause I you know, like sometimes I get interviews for iOS, sometimes I get interviews for full stack, and then have to move back and forth like that. You know, it's so difficult.
Yeah, pick a language you're like master one language. You still yeah, it still looks like you're still learning some of the language. You're able to make some good progress, but it just took long. Let's see
Yeah,
here.
yeah. You like the logic though? Not bad, not bad.
It's not bad. Yeah. Let's
Yeah.
see. I think it got cleaned up a bit, and I
So
mean,
I
there's
move on to the
logic
next round.
errors here. I don't know. I don't know, man. I think there's a bunch of logic errors here. I'm not gonna lie. Like minimum number, your minimum number starts at 0, but technically we can push any integer here. So minimum number, you have a logic error there where you're always gonna return minimum number is 0. But what if I just pop
Yeah.
like 5 or 6 or 7? What? And I say minimum number, it's supposed to be 5, but it's actually 0. So there's a logic error
Uh,
there. I think you need to just be consistent with how you're gonna do the popping, or when it comes to the different functions, just usually you're gonna either throw an exception or return a -1. So I would have brought that up.
oh really? -1, yeah.
Yeah, like be able to handle the edge cases and then tell me right away how you're gonna handle the edge cases. So there's two ways to usually do it. Throw an exception for the edge case if they're trying to peek an element that's empty, or return a -1, or return some sort of something to signal. So a good candidate would say, like somebody who has a lot of experience with a programming language, they'll say, oh, they'll probably discuss the trade-offs. They'll probably most people will probably say I'll throw an exception because they're trying to access something that doesn't exist, and usually
Yeah.
just failing silently. There's two different ways to do it, but most languages will just actually throw an exception if you try to access. And
Yeah.
yeah, I think just focus on, and then for the get minimum, your get minimum won't work. So that's why I wouldn't be able to pass you on because you didn't, or because the logic
Yep.
errors essentially.
Yeah, but if you
But
use OFN, it still work, no?
I mean, I would want it all of one.
Yeah, yeah.
Yeah. But anyways,
That's
yeah, I
good.
think I think just keep practicing. You're getting closer, but you just need to focus on understanding more of the language. Just continue pumping out questions and implementing them from scratch, and covering
Yeah,
all the
yeah,
edge
yeah, I
cases.
know.
Like your is empty was overcomplicated too when you could have just called is empty there.
That's true, that's
But
true.
yeah,
Yeah, yeah, I know, I know. I need to. You have 600 something question, man. That's crazy.
for
Six
which,
something, 600 something leak code solved.
yeah, just keep practicing. You only had
Yeah,
100,
yeah,
and make
yeah.
sure
I
you
know, I
understand
know.
the language inside and out. But
Okay, okay, but when you solve it, do you actually solve it? Do you actually like Google the answer? Let's be honest. Like, how do you do it?
I never usually Google the answer.
So,
I
you,
usually
so
try to
every
come
time,
up.
so how, like you spend like 2 hours on it.
Now, usually I could find the question out within 30 minutes. But yeah, I would never Google usually. When I first started, if I would spend hours on a question. But once you start
Dang.
doing a lot, you'll see there's common patterns. Sometimes I'll look at the solution if I can't really figure it out, but usually I can't. Only hard questions I can't really figure out. But I've done a lot of
Okay,
practice and I went through school for it and stuff. But
okay, okay. Yeah, yeah.
cool. All right. Thanks for
Well,
coming in.
that's very cool. Thank you, man.
All right.
Peace.
See ya. Peace. All right. We got one more person, chat. Gonna take a quick break. Do I know this guy? Oh, Virginia. I think we ran an interview with this other person before. All right, give me a sec. Gonna take a quick break. Yo, chat, how'd the last guy do? What do y'all think? Got one more person. Chat, how's the last person? Gary, what's up?
What up?
What's good? Long time. Or did you already do one of
Ye-
these or no?
Yeah,
Nice.
yeah.
All right.
I did my first one with you like 2 weeks ago.
Nice.
So
What did I ask
yeah.
you?
You asked me like the Pacific Atlantic question.
Oh, yeah, I remember.
And then you also asked me what was the first one? The first one I think was I've forgotten. I think it was like is palindrome, I think.
Yeah. You're the one with actual interviews at these, like, some good companies, right? Coming up.
Yeah, hey, just an update. I nearly have all the Infinity Stones.
Who do you have?
Nearly.
Which companies?
Uh, so I told you last time that I had Google, Microsoft, and Amazon.
Yeah.
So Google hasn't responded to like my times for my phone screen. And then Amazon, I don't know what's going on with them internally, but my recruiter was like, yo, your scheduled interviews are gonna have to be canceled. And then he just left it there. Like
Interesting.
he's trying to look, yeah, he's trying to look for someone for me.
Mhm.
And then Microsoft, I passed the phone screen like literally 2 days after I interviewed with you.
Yeah.
And so I'm now into on the 19th, I have my final rounds with Microsoft.
Nice.
And then just yesterday or 2 days ago, a Meta recruiter reached out to
No
me.
way.
Yeah, so I have a
Shit.
phone. Yeah, I have a phone screen with Meta now on the 26th. So
That's
there you
crazy.
go.
Literally got everything in the acronym now.
Yeah, bro, I
Most
got.
things.
Well, I don't have Apple and Netflix though, but
Yeah.
that's still a good amount of the Infinity Stones.
Yeah.
So,
How are you feeling? What advice did I give you last time?
bro, I'm so nervous. Let me. What? I think the main issue that I had was the first one was because the Atlantic and Pacific, I knew it, and you told me to like pretend that you don't know it, pretty much. And then
Or I think
also
my advice was when you explain it
yeah,
in a way
yeah,
that's doesn't sound
yep,
like you're just regurgitating the solution.
yeah. And then and then you gave me advice to like learn more about the like Python string, like standard string methods and functions, because I hated them, or I hate like working with strings, and so like I had trouble remembering what those actually do or how they work.
Mm-hmm.
So I think that was your advice for the first one. Yeah.
Cool.
So that's where we left off, pretty much.
All right. Okay. You're in this chat. Let's just get straight into this next part then. So
Sure.
we're in this one. We're gonna be designing. There's gonna be multiple parts to this question. Do you like to use Python for your interviews?
Yeah. Python's good,
All right.
and I hate these multiple like phases as well.
This one, we're just gonna be implementing a simple data structure. We're gonna be designing a graph. So implement it with these following. Implement the graph with these following methods.
Oh
For now.
no. Okay. Let me see. Okay. Directed graph. Okay. So we have edges. Add edge.
Yeah.
Okay. So to design a graph, technically, what we're kind of asking here is to also design the nodes themselves. Is it okay if I just start off with like a basic node implementation? Just so that
how are you thinking of so we're gonna be creating this directed graph. right?
Yep.
So
Yeah.
what's the underlying data structure, or
I think so. This is kind of like asking for like an adjacency list. So I think we can start off with using a dictionary to store specifically the nodes and then neighbors as well. Does that make sense?
sure? So we have a dictionary to represent this graph.
Yes. I think that's how.
Sure. I mean, there's multiple
Mm,
ways we can represent it, so I just want you to choose one, and
okay.
maybe we might need to
Yeah.
change it, but not sure yet.
Um, okay. Oh, let me think about this more then. Um, so really, I think my biggest concern right now is how do I represent the edges here? But so the node itself, oh, the node is an int. So yeah, I think I'm comfortable with starting it with a dictionary if we're doing int here or ints for nodes, not like an actual like node class. Um, yeah. So are you good with me starting on that?
So you're gonna use a hash map?
Yeah, pretty
Okay.
much.
Yeah, I'm fine. I'm just curious. What are the other ways that we could store this graph, represent this graph?
Uh, I'm blanking out here. No clue.
Hmm.
Uh,
Okay, that's fine. Let's just go with the hash map.
Sure. Okay. Let me just. Hmm. Sorry. Init. And then we're not inserting anything into the graph class itself, right?
Into the graph class.
Like we're not like we don't have anything for like. Never mind. Never mind. I'm overthinking it, I think.
Yeah.
Okay. Um, like I think neighbors here, right? You can do, and then let me just initialize everything else first. Self node. Add edge from int to int and as edge int to int pass. Oop. Let's not forget the self here. Okay, yeah. And then so I think to add like for here, so if we add a node, we can check first if the node is not already in the neighbors. So if node in self.neighbors, right? And then self neighbors node. We can actually set it as a set because we don't care. We won't have any. Are we going to have duplicates here or like, are we going to have nodes that have like the same?
Like the same edge multiple times?
Yeah.
Would we want that? Can we in our
No. Yeah, no, I don't think so. Okay. And then for add edge, right, we have to add edge. And directed edge from to to. Yeah. First, we have to actually check if they both exist in the neighbors. So if from in self neighbors and to in self neighbors, we is that a let's change it then. Source destination. Let's go. Let's do that. If destination source, let's do that. Let's change it here. Then we can sell out neighbors. Source.
We could assume that we added the nodes before we ever add an edge.
Okay, so in that case, then we don't necessarily need this then, right?
Sure.
And then we can just add destination. Directed edge. Yep. And then also for this one has edge. We can check. So we can check if source is not inside the self.neighbors. Then we'll return false, right?
Has edge source not in self.neighbors. Okay.
Yeah, just because like it's just checking, like if the node that we're the edge is going towards.
Okay, I see. Yeah, makes sense.
Yeah. Okay. And then otherwise, right? Destination. Oh, neighbors.
Otherwise, return destination is in the neighbors. We just
Yep.
need to return a bool here, right? Like, is it if the edge exists?
Yeah. In this case, it would, right? Because we have to check. Like first, we're checking if the source itself is in the neighbors, or technically the adjacency list, right? If it is, because we're storing the source or the neighbors, or sorry, the source. Sorry, if we are storing the destination inside the node or the source, right? Like in this dictionary, then we know there's an edge in there.
This makes sense. Could you go ahead and write some code to test it?
Yeah. Graph equals graph. Okay. And then so let's add node. Let's see. Let's do 5, right? Let's run that first. Cool. So, and then let's do an edge case here and just check for something random, right? Like 5, and then 8. Let's print that 2. Right. Okay, cool, false. And then so let's then add an add edge. Which 5. Let's do, actually. Oh, sorry, we're assuming. So for add edge, we're assuming that both the source and the destination already exist, right?
Yeah.
Okay, So then let's do that. So this should then,
Has an edge from 5
Actually-
to 8.
yeah, this actually still will return false, but if we do it again, because we don't necessarily have the edge set up already, if we do it again, it should return true. Yep.
Nice. What
So
about the other way around? If you go 8 to 5.
graph has edge 8 to 5. Oh. Doesn't.
Is it supposed to?
No, because it's directed.
Yep.
Yeah. So in that case, yeah, it shouldn't. So this makes sense.
Okay. Sounds good. So I want you to implement me a like a DFS and a BFS here.
Oh. Okay. Specifically, what would they be looking for? Pretty much like cycle or what?
I just want you to just write me some code that performs a DFS from any node, any starting node.
Any starting node.
Yeah.
Okay.
So if we call DFS, yeah, with some starting node, it'll perform a depth first search from that node and return me a list of all the nodes it traversed in the order that it traversed them.
A starting node, and then also a destination node, or just a node?
Just a node.
Oh, okay.
What
Were you gonna
would it
have-
matter if we did this?
Okay.
Or I'm wondering, does this question like why would it matter if we know this or the destination?
Oh no, okay, I get you, because directed edge, like we're just gonna go through. Okay, that makes sense. Sorry. Okay, let's do. We can do the perform DFS and actually have a DFS in there, possibly. I think, because like that way, we can just do like the path here, right? Let's do this, and then we can return the path right here. And so for the DFS, we can do a curve.
But let's see. I don't want you to break the API.
Oh,
As
okay.
in, let's write the functions like this. From an API perspective, I don't like the name perform DFS. Like something
Okay,
having
okay.
to call that.
Okay, sure. Let me just do this then. BFS start int, and then I'll pass this for now, and then we can do with BFS. I prefer that much more than BFS. Okay, so let's just invert it. How about that? And then sure path. Am I doing this right? What do you think? Let's just do it here. If okay, so we are looping through DFS, and we're going to start. Let me do like some drawing here. So let's say our dictionary currently is kind of like, you know, 5. Let's do.
We're gonna do BFS first.
No. I'm doing DFS
Okay,
first.
I see.
But I just want to do like a visualization here, just so that I can actually kind of understand how we're doing this. So 6, and then 8, right? So, and then 8. Yeah, okay. In this case, right? So let's say DFS start would be like 5, right? So we go into, currently, obviously, we'll have 5 up in there, right, in the path. And then it's going to go into 6 first. Oh, we don't have 6. Let's do like 4. Okay. Okay, so go into 6, do a DFS on 6, right? And then it will go to 4. And so in that case, we'll have 5 and 6, and then it will DFS into 4, which in this case, it would be 5, 6, 4, 5, 6, 4, right? And then it will actually stop there for 5 or for 6. And then DFS will go into 7 again because we started with 5. In which case, it'll go into 6 again. But I think in this case, we would check. So we would have to check if the node is already in the in our current path. In which case, go ahead.
Like how do you usually perform a DFS? Like what are the different ways to perform a DFS?
You can do an iterative or a recursive DFS. Really, they're pretty much one and the same, right? The iterative just uses a stack, while the recursive uses recursion, or AKA a call stack, right, of the function itself. So.
Okay, so how would you potentially want to do it with a stack, or recursively, or iteratively with a stack? How would you do that?
That's a good question. I don't normally practice DFS with the iterative, but it kind of mirrors BFS, right? I think, because if you have a stack, right, let's pretend the path itself here is the stack itself. We don't necessarily need like a recursive function anymore. In this case, it would just be while stack, right? And then you perform all of your whatever needs to be done within the recursive function within that while stack loop. Does that make sense? Mm-hmm. Did I get there?
Okay. Yeah. I think
no
need to visualize it. Just go ahead and implement it.
Yeah. Okay. Sorry. I was implementing it, or I was visualizing it because I was kind of confused.
Okay.
So you want me to do it with the iterative way?
Yep.
Or?
Yep.
Okay. Let's do then while stack. Okay. Per equals stack pop, right? Stack pop. So in this case, we have to put in the start in there. Yeah, obviously we would have to, otherwise this wouldn't loop through, right? So we check. So then we check if cur is already in path, in which case you just continue, I think, right? Because we don't want to, that's kind of like an endless loop, so to speak. Okay, and then we do a path. Otherwise, we continue, and then we have to add all of their the nodes that they have an edge towards. So in that case, for how do I do this? For and south on, what did I call it again? Neighbors. Per oh, it's a set. Wait. So there we go. Okay. For node in stack.append node. And then in that case, we just path.append per. So that feels deceptively. I don't know if I'm doing that the right way. Like I said, I rarely implement DFS in the iterative way.
Can you walk me through line by line? What's going on here?
Yeah. Okay. So we first initialize this, the stack with the start, right? In this case, and then empty. Obviously, a path is empty. So when we get through the while stack, we pop. So in this case, this would be 5, right? And then we have to check if, well, actually, I never asked. Do we want to go through the all the cycles again? Because that's kind of what I was visualizing here, right? Because eventually we get to 7, right? And we hit the 6. Oh, we do actually. So you don't need this.
We want to view the cycle? Well, we just want to perform a DFS, so print out all of the nodes, but traverse them in a DFS order. If we go through cycles, we're going to end up in an infinite loop.
Right. Yeah, well, let me just yeah,
Okay, sure.
yeah, yeah. So like I said, so our cur right here is 5. Well, let me just implement it this way and see if there's some issue with the logic itself. But 5 isn't in our path, so we go in and we check in the dictionary all the directed edges that it has.
Sure.
So in this case, it would be 6 and 7. So we append that into the stack, and then we append cur into the path. And then, so we go loop through that again. In this case, it would be 6, right? 6 is in our path. And then we also then go into the neighbors or edges technically. And then we see that 4 is an edge. So we append that. So in that case, our stack currently is 7 and 4. And then we append 6 here. So our path is 5, 4 or 5, 6. And then we pop it again. It's 7. 7 is not in our path. 4 node. And then we check it again. So 6 and 8 is in our path, right? Or in our stack.
Yeah. What's the time and space, or what's the time complexity of this DFS?
This would be it would be m times n, where m is the size of the neighbors of the dictionary itself, and then n, or did I say m? Whatever. So it's m, which is the size of the dictionary itself, and then n is the size of technically it would be the size of I think the max, uh, um, a max of like the edges. Whoever
Okay.
has the most
Let's
edges.
see. I think your DFS operation might actually take even longer than that.
Oh, really? Okay.
Like there's this O of N operation happening here.
Oh,
Right, like
okay.
every time you're trying to see if it's already been in the path, you're running another O of N. So it's
Yeah. Okay, so yeah,
when it
that
comes
makes
to
sense.
yeah.
Okay.
So it's kind of like N squared or
Right.
N squared times M.
Right. Oh, it's an interesting one. Um, do you want me to move over to BFS? Actually, so in that case, then would having a visited a set in there, like we can just add the cur or like visited dot add cur again in there, and we just check if it's been visited. All right. Is that
If current node invisited, continue. Okay.
yeah? Or actually, we can also flip this and check. We can check it in here. I just realized that. Right. If node invisited, we can stack. In that case, like we don't care about the node anymore. Does that make sense?
Yep.
Yeah. So, I think that optimizes it. Does it not?
Okay. Go ahead with the BFS now.
Sure. Okay. So BFS, kind of like the iterative, it has a queue, which we will initiate as double-ended queue. Let me just import that. Collections import. Okay. And actually, yeah. Sorry, I forgot to ask. Like the start parameter. This is guaranteed to actually be in
Yep.
the
Yeah.
dictionary, right?
Yes.
Okay. And then we have a visited, which will be start. We can have start in there. Actually, also want start in here. All right. And then we have path here, and then we return path. And then while q, right, cur equals q dot pop left. And then we can just append the path right here, or append cur right here. And then for neighbor, or edge, technically for edge and stuff, neighbors. I don't know why I named it neighbors. Yeah, it's a dictionary. So, oh, did I mess up on that one? I think it's dot get right here. Yeah. Oh. Think curve like that. Yeah. Neighbors. Okay. Get cur, and then this. Let's add self in there. For edge. And then what do we do? Oh, we add it into, we also check if edge invisited, not invisited. Right. Visited, not add edge. And then do set here. Right. Yeah. There we go. Visited add edge, and then q dot append edge, and then we return path. I believe that's the BFS there.
Veg.add. Okay. All right. Let's move. Let's move on to the very last part. I think I'm okay with it for now.
Okay.
So what I want you to do the following.
Mm-hmm.
I'll write it at the bottom, or I'll write it above. Or I'll write it above here. So we update the add edge to support adding a weight, and then write me a function that returns the shortest path between a source and a target.
Oh no. Okay. I'm cooked. Now, how do I do this with my data structure? Let's see. I knew this is where you were going with it, with the
You're
weight.
thinking?
Yeah. That's not very future thinking of me. Because at this point, I mean, we can change it so that it's like a tuple.
Yeah, like does
Right.
much really need to change? I don't know.
I think so. Because I'm trying to think here how we would add in the weight, right? Well, actually, yeah. We can add a tuple. So rather than in the add edges, so it's no longer yeah. It's no longer just the edge itself, but it's the edge slash weight in this case. So, oops. Yeah. So in this case, our self-at neighbors dictionary within the set itself for each node, it's going to be a tuple of the destination and the weight. Does that make sense?
Sure. Yeah.
Makes
sense.
In this case, so then add edge is weight int. In this case, then as well, we can do weight, right? Let's see. Set if add node has edge. I think this one do matter.
I mean that looks fine for adding the weight.
Okay.
How would you get the shortest path between a source and a destination?
Yeah, let's shortest path. I think this is well, this would be, I think, a DFS, right? Or at least I think it would be.
How would it work?
It would be, oh God, this is it Dijkstra's? Which I'll be very completely upfront with you. I don't know how to implement right now. I know I think it uses a heap, right?
Mm-hmm.
But that's all I know about it. So I'm kind of cooked on this one. So this is, source int, target int. Let's just return whatever for now. Because how does the...
Are you familiar with Dijkstra's? You've ever had to do it in school or remember?
Yeah, school was like years ago, 4 years ago.
Yeah.
But yeah, I came across it. Generally, like the problems that I've come across, you can implement like Dijkstra's, but also for those problems, I remember being able to also implement it the DFS way. But I think in this case, can you implement it without using Dijkstra's?
Yep. Not really. Well, if you want to calculate the shortest path, there's only a few shortest path algorithms that are optimal.
Mm-hmm. Yeah. I mean, all I know is, right, you do like a heap.
Yeah.
And I think it's like
yeah. It's fine though. We're already 40 minutes in. So
yeah.
All right, how do you think you did? How was that for you?
This was a fun one, to be honest with you. That first search was pretty good. Seems like I definitely need to hammer down on Dijkstra's. I think, overall, I think this was pretty good.
Yep.
So.
Okay, let's look at it. I think, so for part one, you pretty much sped through it. You're able to do it fast. Implementation made sense. So there's different ways to store the adjacency list. You could use a hash map. Another way is using adjacency matrix. So.
Oh yeah.
But these it doesn't really work for this one, because these nodes are. The matrix is gonna be really sparse. But sometimes if the matrix is dense, using an adjacency matrix is option. But those are just two different ones. I just wanted to see if you could, if you
gotcha.
knew. But
yeah, I thought you were talking about something else. I definitely knew about like the adjacency matrix, but generally, like for the most part, I prefer the dictionary.
Yeah. And then I think for the second question, I think just be able to implement DFS both iteratively and recursively, and be able to do it fast. So I think it took a while, and you were getting tripped up with the implementation. I think it could be cleaned up a little bit. Let's see. So one way you could, let's see, DFS. So in the DFS, let's walk through it. You start at the start.
Yep.
And then you have I think it looks good eventually, but one way you could also just add to visited here. Start.
Yeah, just saw that right now.
What else? Path, dot append. Yeah, it took a bit to optimize it. You started off with unoptimal, but we're slowly able to iterate it.
Yep.
But which is not bad. It showed that you had good problem solving skills. It was genuinely the first time you did it and you were able to solve it. But I think for most interviews, because they won't ask you just straight up DFS, it's always going to be a twist to it. You should be able to pump out a regular DFS pretty fast, and then the iterative or the other version, like the variant that you have to do, it'll make it a lot easier. Because if it's the first time you're implementing iterative DFS in the interview, you might trip up. Let's see. Current pop for node in neighbors. If the node is visited, continue. Okay, this makes sense now. And then one other way would just be, one way that I would just change this up would be something like this.
Oh, you do it at the start? Okay, that makes sense.
While we're visiting it, we're visiting that current node.
Right.
And then if the node is visited, we continue. Otherwise, we just add it to the stack and then we visit it right away, kind of thing.
Gotcha.
Because pretend I have multiple, because I want everything needs to go into the stack exactly once, so I only iterate over it once. if you add it to visited later, sometimes you could add the same element to stack a bunch of times, and it just in some questions it will lead you to it will just, the runtime is just slower, and it could actually ruin your runtime on some questions and get a TLE.
Gotcha.
Yeah.
Cool.
And then you implement the BFS pretty fast, but pretend we're doing this interview, I had to do it really fast. It's pretty much almost just a copy and paste too. You could just copy the BFS right here and just change a couple things, change the queue. But
Yeah,
I think it's fine to implement it from scratch. But yeah, this chat was just saying that. Let's see. And then even your DFS and BFS, you didn't implement them consistently, as in they're slightly different.
Gotcha. Okay.
So they should be pretty much. You should be able to pretty much the same, except for one's using the queue. So
Gotcha.
even with the way you did the visited, so that's yeah. So that's not really anything wrong. It's more just it just shows that you don't have much experience writing it, and and that you need some repetitions, because once you get the repetitions, DFS and BFS you should be like pumping out that boilerplate pretty fast.
Gotcha.
So basically it just showed that you had to think about it a lot. So like where do I do my visited? It should be boilerplate. Like just have this said visited there, and then everything else should be pretty similar. Pop left. So here your path was append up here instead of at the bottom. And then you're doing for edge, but we're actually visiting nodes. Yeah, see, you see how they're both different? Sometimes, like when it comes to just coding in general, a lot of times you would want the functions to be written in a consistent way also for readability.
I definitely I never realized how the iterative DFS looks pretty much like the BFS. So that's definitely a great learning point for me.
Yeah.
That's crazy.
Yeah. And then my last thing would just be just managing the visited array, knowing when to add it and use it. But yeah, I think overall you were able to solve it. Definitely study up on Dijkstra's. Maybe next interview I'll ask you something related to Dijkstra's. We'll see.
Okay. I'll be sure to prep for that.
But Dijkstra's is pretty common. But honestly, they might only ask you that in Google. But it's pretty common. You might actually end up seeing it. I got asked it in a few interviews before.
That sucks.
Yeah, but it's pretty. Honestly, it's boilerplate DFS. Instead of using a stack here, you just do a heap here. It's pretty much boilerplate. So you should understand the boilerplate of DFS and be able to change it up to a BFS, change it up to a Dijkstra. It's pretty easy. It's basically the same as BFS, but with here you're gonna be using your heap instead. And then there's going to be slight changes, but it's going to be pretty much boilerplate to this, honestly.
Okay.
Yeah.
Cool.
All right.
Well, thank you so much.
Yeah, no problem. Do you have another one scheduled soon, right? Or no?
No, I don't.
Yeah, feel free if you want to keep scheduling, do more.
Oh yeah, I'm definitely going to keep scheduling for like the next 3 weeks or so.
Good luck. Let's look at your resume quick. You just sent it over?
I sent it last time. So
let me bring it up. Let's walk through it together because I think it'd be interesting for the chat
to see how.
Yeah. So let me pop this up. So this person, we're gonna do a quick We're gonna quickly look over the resume of somebody who's able to get interviews at every single FANG company. So you got interviews at Meta, Amazon, Google, Microsoft. Am I missing anything?
No, that's it. I mean, there's a couple of startups, but they're not they're not unicorns or anything. So
and then where are you based and where did you go to school?
So my undergrad is in a state school or is from a state university. So it like CS ranking is pretty much crap for that one.
Yeah.
But I'm currently attending OMSCS at Georgia Tech. And yeah, that's my education.
Cool.
Oh, and my location is currently in Virginia.
Nice.
So
you do No Name State. You're going to okay. You graduate. So how many years of work experience you have?
3 years. Yeah, 3 years, like 2 months ago.
Nice. Okay.
Oh.
Nice. Cool. So when it comes to your resume, what are the things that you really wanted to optimize in your resume to make you stand out?
I think the biggest thing, well, actually, it was kind of the impact. Like, I want to emphasize the impact that I've had, like in my teams. Well, technically team. I've only been on one team, but it wasn't like I think the best opportunity that came from my team is the fact that I joined it as a new grad when it literally just started. So like pretty much I was able to kind of own a bunch of things immediately. And I was able to like now at this point, I'm like a subject matter expert on one part of of our team's product. So I think that's like one of the biggest things was like highlighting my ownership and my impact so far. So
Yep. Okay, so you really, when you're working on your resume, the main thing that was going through your head was, how do I show that I actually did a lot of cool stuff and I'm pretty important at my job right now, and like I have a lot of impact at my job. That's kind of what you want to convey in
pretty
your
much.
resume.
Yeah, like I like my so far, like that first line at the
Yeah.
top is probably like I think my crowning moment so far in my team.
Okay.
Because like yeah, like if I go through like the actual uh like the actual details of that, it's pretty crazy, and just in terms of how much my team was budgeted for so technically, so this first bullet point,
Yeah.
we hired we have a vendor that we hire to develop some code of ours because like I said, our team was just starting out, right?
Yeah.
But then I got to a point where I was able to actually take ownership from that vendor, everything that they were doing for our product. And I pretty much like booted them out. Like, so we stopped hiring them because of me, pretty
Nice.
much.
Okay.
So,
All right.
yeah.
Let's check this out. Let me read this from top to bottom. So you at the top have your name and then some links to your LinkedIn, your GitHub. Pretty good.
Mhm.
What's a non here usually put there? Like a website? Underscore?
Yeah.
Or
Yeah,
your
that's like
email,
my
your
personal.
email.
Yeah. Yep.
Okay, you put your phone, email, LinkedIn. Okay, cool. So you have an experience section, a personal projects, technical education, pretty standard. I like these. This is the same sections that I have on my resume.
Mhm.
So cool. You start in July 22. You're now a intermediate software engineer at your company, Fortune 500
Yeah.
company. Okay, let's look at the bullet points. You overhauled end-to-end data integration for a company-wide incentive plan, independently resolving complex issues in a vendor-developed SQL code to reduce associate data and incentive calculation error rate by 90% and eliminating 460K expenditure for vendor development. What's a company-wide incentive plan?
Yeah, so we have our company provides like bonuses based on sales and stuff. So the incentive plan is just pretty much like a
Okay.
bonus plan for like, hey, if you sell this much of this, right, you get a bonus pretty much. So
Okay, nice. So, okay, deployed and developed and deployed a critical status query solution that enabled seamless real-time communication between compensation API and commissions engine, significantly optimizing file transfer and processing workflows, and reducing daily payroll processing from 8 hours to 2. Nice. That enabled. Okay, nice. Enhance payroll workflows by leveraging Groovy and SAP Advanced Workflow, eliminating a workflow error rate of once a month while enhancing system performance. Affecting incentive processing for 7,000. Okay, I like how you have a lot of the metrics. Led user acceptance testing, and I mean, obviously this resume is good. You're able to get your interviews, and coordinated cross-functional. So led the UAT testing and coordinated cross-functional teams for the implementation of a modified incentive plan, resolving over 15 critical issues within 2 weeks to ensure an error-free rollout. Nice. Seems like and chat, he has an interview for all the fan companies pretty much. Yeah, super business focused and showing you're actually working on projects that have a lot of impact on the business. And I like it because you're not just listing out your job responsibilities. Like, I built an API, I wrote some tests, I did requirements gathering. You're actually talking about the business impact that you drove, and those things are kind of like you don't even need to say it because it's kind of implicit with all of the projects you pushed out here. And that's kind of how I like to structure resumes as well.
Yeah.
Pretty good. Let's see. Cool. Let's look up software. You don't put the technologies you used, huh? Like, you don't really talk about that too much?
Yeah, I talked about, like Groovy, SAP Advanced Workflow. But I don't like go explicitly for like what type of SQL I actually work with and stuff like that. But I do talk about them once in a while. I'll sprinkle them in there.
I see. Makes sense. Because like in the projects you actually have it. Okay, so for implement an algorithm using Groovy, SQL, and SAP Advanced Workflow to audit missing and miscounted associated hours, reducing incentive, bonus, overpayment, underpayment by 26,000 annually. That's pretty good. That's a good number, and you make sense exactly how you drop that number or how you generate that metric. Enhance API capabilities by implementing additional endpoints for event consumption, leveraging C#, .NET Core, Azure DevOps, CI/CD. Honestly, it's a really good resume. I think you talk about the metric that you're driving, and then you talk about exactly how you achieve that metric, how you reduced overpayment, underpayment by 26,000, like it made sense there. How you eliminate 90%, 460K of expenditure. Yeah. No, I think this is good. This is a good resume for anybody kind of watching to just take a look at and understand how he actually creates his bullet points, especially for people who actually have a lot of experience. I think for people who are just starting, it's hard to make resumes like this because they don't have the business impact, they don't have the experience yet. So a lot of the times they just default to just writing down job descriptions or pretty much just like roles and responsibilities of what they did. Oh, built an API, wrote some tests, did requirements gathering, right? That's fine at first, but at the end of the day, the bullet points need to shift towards more results-oriented bullet points and actually talk about the business results that you drove within that company. But honestly, yeah, really good resume. Is there any other thing you want to highlight with your resume to the chat?
No, I honestly think just having those, especially the monetary amounts that I could show and also prove when I've talked to the two hiring managers and stuff. I think that's the biggest aspect. I think a lot of companies, because I was asked about those expenditure savings a lot.
Yeah.
So like any time that you like save the company money is like very important to highlight, I
Yeah.
think.
Yeah. And
Um,
honestly, this is a lot funner to talk about in an interview than if somebody just said, "Oh, I built some API," or
yeah.
because I'd be like,
Yeah,
"Okay, what did
exactly.
that API actually do?" Instead of talking about, "Oh, can you tell me more about how you eliminate 460K in expenditure for vendor development?" And then you could just go crazy on that, like talk
Yeah.
about it so deep for a whole hour.
No, literally, like the my interview with my hiring manager, or the hiring manager for Microsoft, that's literally the only thing that we talked about in my resume. He didn't care about like anything else. That's all we talked about. That 460K.
Yeah, it's crazy.
It's kind of crazy. Yeah.
Yeah, cool. All right, thanks for sharing that resume.
Yeah,
I
of
think it's
course.
super helpful for just the community to know what a experienced resume looks like and what an experienced resume who actually gets interviews looks like. And he's only had 3 years of experience. You mentioned you didn't go to a target school. I mean, you do work
Yep.
for a Fortune 500 company that helps, but yeah, like it's a solid resume. So getting some solid experience, having a solid resume, like there's still jobs out there for people.
Yeah. And also like I think a big tip if for like people to actually get that impact is to actually like that is I think the only useful thing about like product managers of like delivery managers is because they also sell
Yeah.
you to like your stakeholders.
Yep.
So like just talk to them like once in a while, like and just like figure out like how they're selling the team
Yeah.
to like stakeholders. Because
Makes sense.
that's generally how I got a lot of these like metrics as well.
Yeah.
Even my one-on-ones with my manager. Like my manager told me about that 460K. And funnily enough, it was because he got chewed out because he didn't spend all of it.
Nice.
So yeah. So like that's yeah. So I think that's like a big tip if you want like metrics
Yeah.
fast.
And
So
how'd you seek out all these opportunities? What were you seeking out these opportunities as in you're thinking, oh, if I take these opportunities, it'll just make me more valuable in the job market?
no, like like literally a lot of these opportunities just fell in my lap. Like I had a good team lead who ramped me up to the team like
Nice.
pretty fast. And he actually like guided me to focus on one thing. And that one thing actually blew up into like owning a good amount
Mm-hmm.
of like a pretty important part of our team. So like I think if you try to get good at one thing in your team, I think that's like a good it's kind of like a trampoline into like everything else. So you build that trust, show that you can actually do work, your ownership eventually increases.
Mm-hmm.
And yeah, I think you like they'll just feed you like the impact that you want.
I see.
So
Cool. All right, man. Good luck. Thanks for showing that and going through that interview.
yeah. Thank you. Thank you.
All
All
right.
right.
See ya,
See you
man.
next time.
See ya.
Bye.
He's an experienced candidate, has few years of experience. Yeah, he's few years of experience. He's doing his masters on I think it's the online or it might be the online masters at the Georgia Tech. The classic one. It's pretty good. It's a really good program. It's pretty hard, I heard. Rejected. Final loop was 4. No leak code. All low level design. What do you mean by low level design? Oh, all object oriented programming. So what kind of role was it? Design board games. I see. I see. More like actual real coding and not just lead code questions. I see. What kind of role was it? Was it a super technical role? Or is it just general SWE? Was it low level role or high level? SDE 1, low level, high level? Or just it's a general SWE track? Interesting. Yeah, I guess maybe they're shifting the type of questions they're asking to, because when I interviewed at Amazon, they just straight asked me lead code questions like threesome, generate parentheses, different ones like that. But that was 4 years ago, so. All right, chat. I'm gonna be streaming again tomorrow, 5 p.m. Pacific time. Might hop on earlier, so. Yeah, I'll message the Discord when I'm in there. But I'll be streaming tomorrow. Maybe I think next week. I don't know about next week. We'll see. Next weekend, I'll check. Let me check. I don't know. Oh no, I'm at a wedding next weekend. I can't really. So next weekend probably, but anyways, thanks for coming in. Appreciate y'all for hopping in and working through some algorithms. I think we covered a lot of ground today. Oh, Cyclops, we can do one anytime. I have you on LinkedIn, right? We could just do like an ad hoc stream where I just ask you a question. Okay, I'll message you. I'll make time for sure. Even tomorrow, maybe I'll start an hour earlier. I'll message you. Yo, message me. Message me on LinkedIn right now. We'll coordinate something. Got to get through the code signal. But yeah, we covered a lot of ground. We had candidates building linked lists, building stacks, building graphs, talking about resumes. We covered a lot of ground today. I think it was a pretty good stream, pretty well. Like all around, we covered a lot of different topics. So thanks for tuning in. Catch y'all tomorrow. We're gonna continue grinding out. It's recruiting season's just started. It's the start of September, so we're gonna be running these all the way up until the end of December, pretty much. And hopefully by then, everyone has their jobs. Everyone has an internship. Paul already like quadrupled his total compensation. So when Paul first came to the channel, he was making around like on 60K, 70, 80, and now he's making a lot of money. I don't know. He's going to talk about it in the chat. He landed an offer at Meta Data Eng. He's moving to Silicon Valley. We're going to talk with him. It's going to be crazy, but I hope everyone in the stream eventually gets to that point soon too. There's already tons of people on the stream who did that for themselves within just when I started. So, good luck everyone. I'll catch y'all in the next video.
This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lead code, beast mode, 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 lead code, beast mode. This is not my main thing, really I'm a coder. Coffee stains and imitations, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over.